There is something in the room with you right now that you have never truly seen. Not the walls, not the furniture, not the objects arranged in the ordinary geometry of your daily life. Something older than any of those things. Something that was there before the room existed, before the building was constructed, before the ground beneath it was shaped by human hands. It is not hiding. It is not waiting. It is simply present the way it has always been present, in every room, in every structure, in every body, in every atom of everything that has ever existed, anywhere in the known universe. And the reason you have never truly seen it is not because it is invisible. It is because it is the majority. It is because the universe, at almost every scale we can examine, is not made of things. It is made of absence. And if you are new here, welcome to Beyond the Universe, where the questions that feel the most ordinary are often the ones with the most unsettling answers. Start with the floor beneath you. It feels solid. It resists your weight. It does not give way. Every instinct you have, every sensation your nervous system has ever processed, confirms that the floor is there, that it is real, that it is full of material substance. And in the practical sense, in the sense that governs your daily life and your survival, that is true. But the practical sense is not the only sense. And the moment you begin to look at the floor not as a surface to stand on, but as a collection of matter, the moment you begin to ask what it is actually made of, the story changes. It changes in a way that is difficult to absorb, not because it is complicated, but because it contradicts something so fundamental to your experience that the mind tends to resist it. If you're still here, still holding the weight of it, still feeling the floor beneath you and the void above you, then you already know why you stay. Subscribe to Beyond the Universe, not because it changes anything, but because for a brief, improbable moment, it means the knowing continues. The floor is made of atoms. Everything is made of atoms. This is not a new idea. You have known it since childhood, probably. But knowing it and truly reckoning with what it means are two entirely different things. An atom is not a small solid ball. It is not a miniature version of the objects you can see and touch. An atom is, by almost any meaningful measure, almost entirely empty. At its center sits a nucleus, a dense cluster of protons and neutrons bound together by forces so powerful they are almost incomprehensible. That nucleus is extraordinarily small. If you were to take a single atom and expand it to the size of a large sports stadium, the nucleus at its center would be roughly the size of a marble sitting on the field. A single marble, in a stadium. And the rest of that stadium, every seat, every corridor, every open space from the field to the roof, would be the domain of the electrons. But here is where the picture becomes stranger still. The electrons are not orbiting the nucleus the way planets orbit a star. That image, the one from old textbooks with neat circular paths and labeled shells, is a simplification that borders on fiction. Electrons do not travel in fixed orbits. They exist as quantum probability distributions, smeared across regions of space, present not as tiny solid particles tracing predictable paths, but as something more like standing waves of possibility. They occupy volumes. They define the outer boundary of the atom not by being there in any fixed sense, but by making it statistically improbable for another electron to occupy the same region. The solidity you feel when you press your hand against a surface is not the solidity of matter touching matter. It is the electromagnetic repulsion between electron clouds. Two surfaces resist each other not because they are full, but because their emptiness refuses to overlap. This is the first contradiction. The world feels full. The world is, at its most fundamental accessible level, almost entirely empty. The ratio is not close. It is not as though matter is 50% empty, or even 90% empty. The empty space inside a single atom dwarfs the space occupied by its nucleus by a factor so extreme that ordinary language struggles to carry it. If you could somehow remove all the empty space from every atom in every human body on Earth, all 8 billion of us, the remaining matter would compress into a volume roughly the size of a sugar cube. Not a building, not a room, a sugar cube. That is how much of what you call the physical world is actually occupied by anything resembling substance. And yet the floor holds you, the walls stand, the objects in your room maintain their shapes. The universe, at the scale of human experience, behaves as though it is full of things. This is not an illusion in the dismissive sense. The forces that govern atomic structure are real. The electromagnetic interactions that make matter feel solid are real. But they are forces operating across emptiness. They are rules written into the geometry of absence. The substance of the world is not in the matter. It is in the relationships between vanishingly small concentrations of matter, separated by proportionally vast distances of nothing. Now step back, not metaphorically, conceptually. Pull your perspective outward from the atomic scale and return to the human scale, and then keep going. Leave the room, leave the building, rise above the city, above the clouds, above the atmosphere. You are now looking at the Earth from a distance, and the Earth is a remarkable thing. It is dense with life, with geology, with oceans and atmosphere, and the accumulated complexity of 4.5 billion years of planetary history. It is, by any cosmic standard, an extraordinarily rich and structured object, and it is also, in the context of what surrounds it, almost incomprehensibly alone. The Moon is the nearest significant body to Earth. On the diagrams you grew up with, the Moon appears close. It appears to be just off to the side, a companion within easy reach. The reality is different. The average distance between the Earth and the Moon is roughly 384,000 kilometers. If you were to drive a car at highway speed without stopping, it would take you more than 5 months to reach it. The Moon is not nearby. It is simply the nearest thing, and nearest is a relative term that loses its comfort the moment you examine it honestly. But the Moon is intimate compared to what lies beyond it. The Sun sits at an average distance of about 150 million kilometers from Earth. Light, the fastest thing in the universe, takes approximately 8 minutes to cross that distance. If the Sun were to vanish at this moment, you would not know for 8 minutes. You would sit in what felt like an ordinary day for 8 minutes before the light stopped arriving. That delay is not a technical curiosity. It is a statement about the architecture of the solar system. The Sun is not close. It is simply the dominant object in a region of space so large that the human mind was not built to hold it. And the Sun is only the beginning of the solar system's scale. The outer planets are not arranged like the diagrams suggest. Those familiar images, the ones with all 8 planets lined up in a neat row with roughly equal spacing, are lies of convenience. They are drawn that way because the truth would make the inner planets invisible. Neptune, the outermost of the 8 recognized planets, orbits the Sun at an average distance of roughly 4.5 billion kilometers. Light takes more than 4 hours to travel from the Sun to Neptune. If you place the Sun and Neptune at opposite ends of a football field, Earth would be less than 3 meters from the Sun. The outer solar system is not a neighborhood, it is a wilderness. Beyond Neptune lies the Kuiper Belt, a region of icy bodies and dwarf planets extending further still. Beyond that, at distances that begin to strain even the concept of the solar system, lies the Oort cloud, a vast theoretical shell of cometary bodies that may extend nearly a quarter of the way to the nearest star. The solar system does not end cleanly. It dissolves into interstellar space gradually, its influence fading over distances so enormous that the Sun itself becomes just another point of light, indistinguishable from the stars you see on a clear night. And this leads to something more disturbing. The nearest star to our Sun is Proxima Centauri, a small red dwarf located approximately 4.2 light-years away. A light-year is the distance light travels in 1 year, moving at roughly 300,000 kilometers per second. 4.2 light-years is approximately 40 trillion kilometers. The fastest spacecraft humanity has ever launched, the Voyager probes, travel at roughly 60,000 kilometers per hour. At that speed, it would take Voyager approximately 75,000 years to reach Proxima Centauri. 75,000 years. The entirety of recorded human history spans roughly 5,000 years. The distance to the nearest star is 15 times longer than all of recorded human civilization, measured not in years but in travel time at the fastest speed we have ever achieved. And Proxima Centauri is the nearest one. The Milky Way contains somewhere between 200 and 400 billion stars. They are not evenly distributed, but even in the denser regions of the galaxy, the average distance between stars is measured in light-years. The galaxy is not a solid structure. It is not a disk of continuous light. It is a collection of points, each one separated from its neighbors by distances that would take tens of thousands of years to cross at any speed we can currently produce. The Milky Way is, by volume, almost entirely empty. The stars within it are like grains of sand scattered across a continent, each grain separated from the next by kilometers of open air. Try to hold that image, not the image from astronomy photographs, the ones that show the galaxy as a luminous spiral, dense with color and light. Those images are beautiful, and they are real in the sense that the light they capture is real, but they are also deeply misleading. The brightness you see in those images is the accumulated light of billions of stars compressed into a single photograph, their individual separations invisible at that scale. If you could somehow stand inside the Milky Way and look around, the sky would be dark. There would be stars, yes, but they would be points of light separated by vast stretches of blackness. The galaxy would not feel like a city. It would feel like a desert at night, with occasional fires burning at enormous distances from one another. But it goes deeper. The Milky Way is not alone. It is part of a collection of galaxies called the Local Group, which contains more than 50 galaxies of various sizes, including our own and the Andromeda Galaxy, which is the largest member of the group. The Local Group spans roughly 10 million light-years. 10 million light-years. The distance to Proxima Centauri, which already felt impossible, is 4 light-years. The Local Group is 2.5 million times larger than that distance, and the Local Group is not large by cosmic standards. It is a small, gravitationally bound cluster in a universe that contains hundreds of billions of galaxies. The Andromeda Galaxy, the nearest large galaxy to the Milky Way, sits approximately 2.5 million light-years away. The light reaching your eyes when you look at Andromeda on a clear night left that galaxy 2.5 million years ago. At that time, our ancestors were early hominids, walking upright on the African savanna, with no language, no fire, no concept of the sky above them as anything other than a ceiling. The light you are seeing is not Andromeda as it is. It is Andromeda as it was, before humanity existed in any recognizable form. The night sky is not a window, it is an archive. Everything you see when you look up is the past, arriving late, from distances that make the word far feel inadequate. Beyond the Local Group, the universe organizes itself into structures of increasing scale and increasing emptiness. Galaxy clusters are collections of hundreds or thousands of galaxies bound together by gravity, embedded in vast halos of dark matter. Superclusters are collections of clusters, spanning hundreds of millions of light-years, and threading through all of this, connecting the clusters and superclusters like the strands of an enormous three-dimensional web, is the cosmic web, the large-scale structure of the universe itself. The cosmic web is one of the most extraordinary things science has ever revealed. It is a filamentary network of matter, both visible and invisible, stretching across the observable universe. Galaxies and galaxy clusters are concentrated along the filaments and at the nodes where filaments intersect. Between the filaments, between the nodes, between the clusters and the walls of galaxies, there are voids, and the voids are not small. Cosmic voids are regions of space where the density of matter is significantly lower than the cosmic average. They are not simply gaps between galaxies. They are enormous coherent structures, some of them spanning hundreds of millions of light-years in diameter. The Buddha's void, one of the most studied large voids, spans roughly 330 million light-years. If you were somehow placed at the center of the Buddha's void and looked in any direction, you would see almost nothing. Not darkness in the way a room is dark when the lights are off. Darkness in the way that space between galaxies is dark, which is to say a darkness so complete and so vast that the nearest galaxy would be tens of millions of light-years away in any direction. You would be surrounded by a sphere of near total absence 300 million light-years across, and the Buddha's void is not the largest. Astronomers have identified supervoids, regions even more depleted of matter, even more vast, even more empty. The universe, when examined at its largest scales, is not a uniform distribution of matter. It is a foam-like architecture of dense filaments and walls surrounding enormous bubbles of near-nothingness. The matter, all the stars and galaxies and clusters and everything we have ever observed, occupies only a small fraction of the total volume of the universe. The majority of the universe, by volume, is void. This is the picture that emerges when you step back far enough. Not a universe teeming with stars and galaxies in every direction. Not a cosmic ocean full of light and structure. A vast, mostly empty architecture, where matter has gathered into thin filaments and nodes, leaving behind enormous regions of space that contain almost nothing. The universe is not full. It is, by almost any measure you care to apply, almost entirely empty. And the things that exist within it, the stars, the planets, the galaxies, the clusters, everything that has ever been observed or measured or imagined, are not the rule. They are the exception. They are the rare disturbances in a structure whose dominant feature is absence. But here is where the story takes its first real turn, because the emptiness is not passive. The void is not simply the space between things, waiting quietly, while matter does the interesting work. The emptiness of the universe is active. It has properties. It participates in the history of everything. And understanding this, truly sitting with it, is where the unease begins to deepen into something harder to name. Consider what we mean when we say that space is empty. In everyday language, empty means nothing is there. But in physics, the vacuum of space is not nothing. It is a physical medium with measurable properties. It has a geometry, described by the equations of general relativity, that can curve and warp in the presence of mass and energy. It can carry gravitational waves, ripples in the fabric of space-time itself, produced when massive objects accelerate. It is threaded with fields, the electromagnetic field, the gravitational field, and others, that extend through all of space and govern the behavior of matter wherever matter exists. The vacuum is not an absence of physics. It is a physical condition, and that condition is not neutral. There is also the question of what the vacuum contains at the quantum level. Quantum field theory, the most precisely tested framework in the history of physics, describes the vacuum not as empty, but as a seething ground state of quantum fields. Virtual particles, pairs of particles and antiparticles flicker in and out of existence on timescales so short they cannot be directly observed, but their effects are measurable. The Casimir effect, a tiny but real force between two uncharged metal plates placed very close together in a vacuum, is one of the most direct demonstrations that the vacuum is not nothing. The plates are pushed together by the difference in vacuum energy between the space inside them and the space outside. The void pushes. The nothing has pressure. This is not a comfortable idea. It means that the emptiness of the universe is not simply the absence of matter. It is a physical reality with its own structure, its own energy, its own behavior, and it means that when we say the universe is mostly empty, we are not saying the universe is mostly nothing. We are saying the universe is mostly something we do not fully understand, something that does not shine, does not interact with light in any way we can directly detect, and yet shapes the behavior of everything that does. And this leads to something more disturbing, because the emptiness is not the only invisible thing. The universe contains matter that does not shine. It contains energy that does not interact with light. It contains forces and fields and structures that leave no direct trace in any telescope ever built. And these invisible components are not minor corrections to the cosmic inventory. They are the dominant terms. They are the majority. And the matter you can see, the stars, the gas, the dust, the planets, everything that has ever been observed by any instrument in the history of science, is a small fraction of what actually exists. The first hint of this came from the motion of galaxies. When astronomers measured how fast stars orbit the centers of their galaxies, they found something that did not fit. The stars at the outer edges of galaxies were moving too fast. According to the laws of gravity, stars far from the galactic center, where most of the visible mass is concentrated, should orbit more slowly, the way the outer planets of the solar system orbit the sun more slowly than the inner ones. But they did not. They orbited at roughly the same speed as stars much closer to the center. The rotation curves of galaxies were flat when they should have been declining. Something was providing additional gravitational pull, something that was not visible, something that was not emitting light, not reflecting light, not absorbing light in any detectable way, something that was simply there, exerting gravity, shaping the motion of stars, and remaining completely invisible to every instrument pointed at it. That something was given a name, dark matter, and the name is honest in its admission of ignorance. We do not know what dark matter is. We know it exists because of what it does. We know it is not ordinary matter, not atoms, not protons and neutrons and electrons arranged in the familiar structures of chemistry and physics. We know it does not interact with the electromagnetic force, which is why it does not shine and cannot be seen. We know it interacts gravitationally because its gravitational effects are what revealed it, and we know it is everywhere, not just in the outer regions of individual galaxies, but in halos surrounding entire galaxies, in the spaces between galaxies within clusters, and woven through the cosmic web itself. The amount of dark matter in the universe is not trivial. Current estimates suggest that dark matter accounts for roughly 27% of the total energy content of the universe. Ordinary matter, the kind made of atoms, the kind that makes up stars and planets and you and everything you have ever touched or seen or imagined, accounts for roughly 5%. 5%. The universe is not mostly made of the stuff you are made of. The universe is mostly made of things you cannot see, cannot touch, and do not yet understand. The matter that has been the subject of all of human science, all of chemistry, all of biology, all of physics as practiced for centuries, is a minor constituent of the cosmic inventory. But it gets worse, because dark matter, for all its strangeness, at least behaves in a way that is conceptually familiar. It has mass. It exerts gravity. It clusters. It forms structures. It participates in the gravitational dynamics of the universe in ways that, while invisible, are at least analogous to the behavior of ordinary matter. Dark matter is strange, but it is strange in a way that fits within the framework of things that exist and interact and have consequences. What comes next does not fit so neatly. What comes next is something that does not merely exist in the emptiness. It appears to be the emptiness itself, behaving in a way that defies every intuition about what empty space should do. In 1998, two independent teams of astronomers were doing something that seemed straightforward. They were measuring the distances to a particular type of exploding star, a type Ia supernova, which burns with a brightness so consistent and so well understood that astronomers use these explosions as cosmic rulers. By comparing how bright a supernova appears from Earth with how bright it actually is, you can calculate how far away it is with remarkable precision. The teams were using this method to measure the expansion of the universe, specifically to determine whether the expansion was slowing down. Gravity pulls matter together. The universe began with an enormous outward expansion. Logic suggested that gravity should be gradually decelerating that expansion, the way a ball thrown upward slows as it rises. The question was simply how much the expansion had slowed. The answer was supposed to be a number, a rate of deceleration, a confirmation of the expected physics. The answer they got was not a number describing deceleration. The answer they got was that the expansion was not decelerating at all. It was accelerating. The universe was not slowing down. It was speeding up. Distant galaxies were not merely moving away from us. They were moving away from us faster than they had been moving away from us in the past. The expansion of space itself was increasing. Something was pushing the universe apart, not from any particular point, not from any identifiable source, but from everywhere, from the fabric of space itself, uniformly, relentlessly, and with increasing effect over time. This discovery earned its principal investigators the Nobel Prize in Physics in 2011. It also introduced into the scientific vocabulary a term that is, in its honesty, one of the most unsettling phrases in the history of human knowledge. The unknown driver of this accelerating expansion was named dark energy, and the name is not merely an admission of ignorance about what it is. It is an admission of ignorance about almost everything concerning it. We do not know what dark energy is. We do not know where it comes from. We do not know whether it is a property of space itself, a constant energy density inherent to the vacuum, or whether it is something more dynamic, a field that evolves over time. We do not know whether it will remain constant or whether it will change. We know it exists because the universe is accelerating, and something must be causing that acceleration. Beyond that, the darkness in the name is genuine. What we do know is its proportion. Dark energy accounts for approximately 68% of the total energy content of the universe. 68%, more than 2/3 of everything the universe contains, in terms of its energy budget, is this unknown, invisible, structureless thing that appears to be woven into the fabric of space itself. Dark matter accounts for another 27%. Ordinary matter, atoms, stars, planets, gas, dust, everything you have ever known, accounts for the remaining 5%. The universe is not mostly made of the things we understand. It is mostly made of two things we do not understand at all, one of which appears to be actively working to tear the universe apart. And this is where the scale of the emptiness takes on a new dimension, because dark energy is not concentrated anywhere. It is not a substance that pools in certain regions. It is, as far as we can determine, uniformly distributed throughout all of space. Every cubic meter of the universe, including the cubic meters that contain nothing else, contains dark energy. The void is not empty of dark energy. The void is, in a sense, made of dark energy. The emptiness of the universe is not merely the absence of matter. It is a positive physical condition, a condition that has energy, that has consequences, and that is currently winning the largest contest in the history of the cosmos. The consequence of dark energy's dominance is the accelerating expansion of the universe, and the consequences of that acceleration are worth sitting with carefully, because they are not abstract. They are not distant philosophical concerns. They are the mechanism by which the universe is, right now in this moment, becoming more isolated, more divided, and more empty than it was yesterday. The expansion of space means that the distance between objects that are not gravitationally bound to each other is increasing. Galaxies that are not part of the same gravitationally bound cluster are moving apart, and because the expansion is accelerating, they are moving apart faster and faster with each passing moment. There is a concept in cosmology called the Hubble radius, sometimes called the cosmological horizon, and it describes something that is genuinely difficult to absorb. Because the universe is expanding, and because that expansion is accelerating, there is a distance beyond which the recession of space is so fast that light emitted from objects at that distance can never reach us, not because the light is too slow, not because there is anything blocking it, but because the space between us and those objects is expanding faster than light can cross it. Light moves at the fastest speed the universe permits, but space itself is not bound by that speed limit. Space can expand at any rate, and in the accelerating universe, the space between us and sufficiently distant objects is expanding faster than light can travel. This means that the observable universe, the region from which light can in principle reach us, is not the same as the entire universe. It is a bubble centered on us, defined not by the edge of the universe but by the limit of what can ever communicate with us. Beyond that bubble, there are galaxies, perhaps an enormous number of them, perhaps an infinite number, that are already beyond any possible future contact. Not because we lack the technology to reach them, not because we have not tried, but because the geometry of an accelerating universe makes contact with them physically impossible, now and forever. But it gets worse, because the cosmological horizon is not fixed, it is shrinking. As the expansion accelerates, the boundary of what can ever reach us is moving inward. Galaxies that are currently just within the observable universe, galaxies whose light is still reaching us, will eventually cross the horizon. Their light will continue to arrive for a time, red-shifted and dimmed by the expansion, but eventually it will stop, not because the galaxies have gone dark, but because the space between us and them will be expanding so fast that even their light can no longer make progress toward us. They will, from our perspective, simply fade. They will redshift into invisibility, their light stretched by the expansion until it falls below any detectable frequency, and then they will be gone, not destroyed, not dead, simply unreachable, simply beyond. Think about what this means for the night sky. The stars and galaxies you see when you look up are not a permanent feature of the universe. They are a temporary condition. The universe is in a particular phase right now, a phase in which the expansion has not yet carried most galaxies beyond the horizon, in which the light from billions of galaxies is still arriving, in which the sky is still populated with observable structure. But this phase will not last. Over timescales that are long by human standards but short by cosmic ones, the galaxies beyond our local group will fade and disappear from view. The night sky will become darker, not because the stars have burned out, though that will happen too, but because the universe will have expanded to the point where the light from distant galaxies can no longer reach us. Astronomers in the far future, if any exist, will look out at a universe that appears far emptier than the one we observe today. They will see the galaxies of the local group, which are gravitationally bound and will not be carried away by the expansion. But beyond that, they will see almost nothing. The cosmic web, the filaments and clusters and superclusters that we can map today, will be invisible to them. Not because the structures will have dissolved, but because the light from them will no longer be arriving. Those future observers, if they exist, will have no way of knowing that the universe contains hundreds of billions of galaxies beyond their horizon. They will look out and see a small, isolated island of matter, surrounded by what will appear to be an infinite, featureless void. They will have no evidence that anything else exists, and they will be, in a meaningful sense, correct. For them, nothing else will be reachable, nothing else will be real, in any practical sense. This is one of the most quietly devastating implications of dark energy. It does not destroy the universe. It does not cause an explosion or a collapse. It simply separates. It takes the cosmic web, the grand architecture of matter that took billions of years to assemble, and it slowly, inexorably pulls it apart. Not violently, not dramatically, quietly, the way a tide pulls a message in a bottle out to sea, not with force, but with the patient, indifferent geometry of an expanding ocean. And the isolation is not only between galaxy clusters. Within the local group itself, the dynamics are different. The Milky Way and Andromeda are gravitationally bound, and they are actually approaching each other. In roughly 4.5 billion years, they are expected to merge, combining their stars and gas and dark matter halos into a single, larger galaxy. This merger will not be a collision in the way two cars collide. The stars within each galaxy are so widely separated that most of them will pass through the merger without directly hitting anything. The galaxies will interpenetrate, distort, and eventually settle into a new combined structure. But this merger, dramatic as it sounds, is happening against a backdrop of increasing cosmic isolation. The local group will merge and consolidate, but the rest of the universe will continue to recede. The merged galaxy will be an island in an expanding void, its nearest neighbors growing more distant with every passing moment. Now pull back further, not just in space, but in time, because the story of the universe's emptiness is not only a story about where things are, it is a story about where things are going. And where things are going, on the longest timescales, is toward a condition that makes the current universe look crowded by comparison. The universe is approximately 13.8 billion years old. In that time, it has gone through phases of extraordinary activity. The first stars ignited a few 100 million years after the Big Bang, ending the cosmic dark ages and beginning the era of light. Galaxies formed and grew, merging and evolving over billions of years. The cosmic web assembled itself under the influence of gravity and dark matter. Stars were born in enormous numbers, burned through their fuel and died, seeding the universe with the heavier elements that would eventually make planets and chemistry and life possible. The universe has been, for most of its history, a place of ongoing creation. But that era of creation has a limit. Stars are not made from nothing. They are made from gas, primarily hydrogen and helium, the lightest elements, the ones produced in the first minutes after the Big Bang. That gas is a finite resource. As stars form and burn and die, they convert hydrogen into heavier elements, and those heavier elements are not easily recycled back into new stars. Some gas is returned to the interstellar medium when stars die, and some of that gas can form new stars. But the process is not perfectly efficient. With each cycle, some material is locked away in stellar remnants, in white dwarfs and neutron stars and black holes, unavailable for future star formation. The reservoir of star-forming gas is being depleted. The rate of star formation in the universe has already been declining for billions of years. It peaked roughly 10 billion years ago, when the universe was young, and gas was abundant, and galaxies were actively colliding and merging, triggering enormous bursts of star formation. Since then, the rate has been falling. The universe is forming fewer new stars today than it was 5 billion years ago. It will form fewer still in another 5 billion years. The era of stars, the era we are currently living in, is not the permanent condition of the universe. It is a phase, a relatively brief phase, in cosmic terms, during which the universe happens to contain enough gas in the right conditions to sustain the ignition of new suns. This phase will end, not suddenly, not with any dramatic event. It will simply wind down, the way a fire winds down when the fuel runs low. The gas will be consumed or locked away. The rate of star formation will approach zero. The last new stars will ignite, burn for their allotted time, and go dark. And after that, the universe will enter a phase that has no analog in human experience, a phase in which the stars that remain are aging, cooling, and dying, and no new ones are being born to replace them. The timescales involved are almost impossible to communicate. The sun has been burning for about 4.5 billion years, and has roughly another 5 billion years of hydrogen fuel remaining. Larger stars burn hotter and faster, exhausting their fuel in millions of years. Smaller stars, the red dwarfs, burn so slowly and so efficiently that they can sustain fusion for trillions of years. The smallest red dwarfs may burn for 10 trillion years or more, 1,000 times longer than the current age of the universe. So the era of stars will not end soon. It will not end in any time frame that is meaningful to human civilization, but it will end, and when it does, the universe will be a very different place. In the far future, after the last red dwarfs have exhausted their fuel and gone dark, the universe will be populated primarily by stellar remnants. White dwarfs, the cooling cores of stars like the sun, will drift through the darkness, slowly radiating away their residual heat over timescales of quadrillions of years. Neutron stars, the dense remnants of more massive stars, will spin down and cool. Black holes, the most extreme remnants of the most massive stars, will persist far longer than any other structure, their gravity holding them together against the slow dissolution that will eventually claim everything else. But it gets worse. Because even the white dwarfs, those slowly cooling embers of dead stars, may not be permanent. There is a theoretical process, not yet observed but predicted by certain extensions of the standard model of particle physics, called proton decay. Protons, the positively charged particles at the heart of every atomic nucleus, may not be stable forever. They may, over extraordinarily long timescales, spontaneously decay into lighter particles. The predicted timescale for proton decay, if it occurs, is at minimum around 10 to the power of 34 years. That number is so large it is essentially meaningless to write out in full. The current age of the universe is approximately 10 to the power of 10 years. Proton decay, if it happens, would occur on timescales a trillion times longer than the current age of the universe. If protons decay, then ordinary matter is not permanent. The white dwarfs will dissolve. The neutron stars will dissolve. The planets will dissolve. Every atom in the universe, every proton in every nucleus of every atom, will eventually decay into radiation and lighter particles. The solid, persistent, seemingly durable stuff of the universe will simply cease to exist, not through any violent process but through the slow statistical inevitability of quantum decay. Matter will not be destroyed in any dramatic sense. It will simply stop being matter. It will become radiation, spreading outward through an expanding universe, thinning and cooling and redshifting until it is indistinguishable from the background. And through all of this, the black holes will remain. Black holes are, in a sense, the most durable structures the universe produces. They are regions where gravity has become so extreme that nothing, not matter, not light, not information in any form we understand, can escape. They grow by consuming matter and radiation. They merge with other black holes, and they persist in principle for timescales that dwarf even the timescale of proton decay. A stellar mass black hole, the kind produced by the death of a massive star, would take approximately 10 to the power of 67 years to evaporate through Hawking radiation, the slow quantum process by which black holes are theorized to lose mass over time. A supermassive black hole, the kind that sits at the center of a large galaxy, would take far longer, perhaps 10 to the power of 100 years or more. Hawking radiation is worth pausing on, because it is one of the most remarkable and unsettling predictions in theoretical physics. Stephen Hawking showed in 1974 that black holes are not perfectly black. Due to quantum effects near the event horizon, black holes should slowly emit a faint thermal radiation, losing mass and energy in the process. Over time, a black hole will evaporate completely, ending in a final burst of radiation. This process is so slow for large black holes that it is completely negligible compared to any other process in the current universe. But in the far future, after all other matter has decayed or been consumed, after the stars are gone and the white dwarfs have dissolved and the universe has expanded to a state of near total emptiness, the black holes will still be there, slowly, imperceptibly evaporating, radiating their last energy into an increasingly cold and empty cosmos, and then they too will be gone. The last black hole will evaporate. Its final burst of Hawking radiation will spread outward through a universe that is, by that point, almost unimaginably empty and cold. There will be no matter, no stars, no planets, no atoms, no structures of any kind that we would recognize. There will be photons, the particles of light, spreading through an expanding universe, their wavelengths stretched by the expansion to lengths so enormous they carry almost no energy. There will be neutrinos, ghostly particles that barely interact with anything, drifting through the void. There may be the faint remnants of Hawking radiation from the last evaporated black holes, and there will be dark energy, still present, still driving the expansion, still doing whatever it is that dark energy does, in a universe that contains almost nothing for it to act upon. This is the condition that physicists call the heat death of the universe, or sometimes the Big Freeze. It is not a death in the dramatic sense. There is no explosion, no collapse, no singular moment of ending. It is a gradual approach toward a state of maximum entropy, a state in which the universe has reached thermodynamic equilibrium, in which there are no more temperature gradients, no more concentration of energy in any form that can do work, no more structures capable of storing or processing information. It is a state in which the universe is not destroyed but simply exhausted, a state in which everything that could happen has happened, and nothing new can begin. Entropy is the concept at the heart of this fate, and it is worth understanding not as a technical term, but as a physical reality. Entropy is, in the most intuitive sense, a measure of disorder, or more precisely, a measure of the number of ways a system can be arranged. A highly ordered system, like a crystal, or a star, or a living cell, has low entropy. A disordered system, like a gas dispersed uniformly through a large volume, has high entropy. The second law of thermodynamics states that in any closed system, entropy tends to increase over time. Order tends toward disorder. Concentrated energy tends to spread out. Structures tend to dissolve. This is not a law that can be broken. It is not a tendency that can be reversed by any process we know of. It is a fundamental feature of the universe. The universe began in a state of extraordinarily low entropy. The Big Bang produced a hot, dense, highly ordered initial condition from which all subsequent structure emerged. Stars formed because gravity concentrated matter into dense regions where nuclear fusion could occur, creating local pockets of low entropy at the cost of increasing entropy elsewhere. Life emerged as a local temporary reduction in entropy, sustained by the flow of energy from the sun, which is itself a local concentration of low entropy that will eventually be exhausted. Every structure in the universe, every galaxy, every star, every planet, every organism, every thought, is a temporary eddy of order in a universe that is, on the whole, moving inexorably toward disorder. The heat death is the endpoint of this process. It is the state toward which the second law of thermodynamics has been driving the universe since the moment of its beginning. It is not a surprise. It is not a malfunction. It is the expected outcome of the physics that governs everything. And it is, in its way, the most complete expression of the emptiness that has been the universe's dominant feature all along. The universe began with a vast amount of usable energy concentrated in a small space. It has been spending that energy ever since, spreading it out, diluting it, converting it from useful forms to useless ones. The heat death is simply the moment when the spending is complete, when the account is empty, when there is nothing left to spend. But there is something even more unsettling than the heat death itself. It is the question of what the heat death means for the possibility of observation, of memory, of any form of awareness or record. Because the universe, in its current phase, is a place where information can be stored and processed. Stars emit light that carries information about their composition and temperature. Planets record the history of their formation in their geology. Living organisms encode information in their DNA and process it in their nervous systems. Civilizations build libraries and databases and transmit signals across space. The universe right now is a place where things can be known, remembered, and communicated. In the heat death, none of this is possible. A universe at maximum entropy is a universe in which information cannot be stored, because storage requires structure, and structure requires low entropy. It is a universe in which nothing can be computed, because computation requires energy gradients, and energy gradients have been eliminated. It is a universe in which nothing can be observed, because observation requires a difference between the observer and the observed, and in a state of maximum entropy, all differences have been erased. It is a universe in which the concept of an event, something happening, something changing, something occurring, has no meaning, because nothing changes, nothing happens, nothing occurs. The universe simply is, in a state of perfect, featureless, eternal sameness. And this raises a question that is not scientific but is impossible to avoid, once you have followed the science this far. If the universe reaches a state in which nothing can be observed, in which no information can be stored or processed, in which no record of anything that ever happened can be maintained, does the past still exist in any meaningful sense? The stars that burned for billions of years, the galaxies that assembled over cosmic time, the planets that formed and evolved and in some cases gave rise to life, the civilizations that arose and built and wondered and looked up at the sky, all of this will have happened. But in a universe at maximum entropy, there will be no way to know that it happened. There will be no record. There will be no memory. There will be no observer to whom it matters. This is not a comfortable thought. It is not meant to be. It is the logical consequence of following the physics to its conclusion, of taking seriously what the universe is telling us about its own nature and its own trajectory. The universe is not a permanent stage on which the drama of existence plays out forever. It is a temporary condition, a brief phase of low entropy in a cosmos that began with an extraordinary concentration of order and is slowly, inevitably, spending that order down to nothing. The stars are not eternal, the galaxies are not eternal, the atoms are not eternal, and the structures built from atoms, the planets, the organisms, the civilizations, the memories, are not eternal either. What is eternal, or at least what persists longest, is the emptiness, the void, the expanding, dark, cold, featureless space that was always the majority of the universe and will eventually be all of it. The matter was always the exception. The light was always temporary. The structure was always borrowed from a finite reserve of order that has been declining since the beginning, and the emptiness was always there, surrounding everything, underlying everything, waiting with the patience of something that does not need to wait, because it has no experience of time, no awareness of duration, no sense of before or after. There is a particular quality to this realization that is different from ordinary scientific knowledge. Most scientific discoveries expand the world. They reveal new things, new possibilities, new connections. The discovery of the cosmic web revealed that the universe has structure on scales we had not imagined. The discovery of exoplanets revealed that planets are common, that the solar system is not unique, that the raw materials for worlds exist throughout the galaxy. These discoveries are enlarging. They make the universe feel richer, more populated, more full of possibility. But the discoveries we have been tracing here move in the opposite direction. They reveal not richness, but absence, not fullness, but emptiness, not permanence, but dissolution. They are discoveries that make the universe feel not larger but lonelier. And yet there is something in the human mind that resists this conclusion, something that keeps reaching for a counter-argument, a qualification, a reason why the emptiness is not as total as the physics suggests. This resistance is not irrational. It is, in fact, one of the most interesting things about the situation, because the mind doing the resisting, the mind that looks at the data and feels the pull of unease and wants to find a way out, is itself a product of the universe it is trying to understand, the atoms in your brain, the electrochemical processes that constitute your thoughts, the very capacity for wonder and dread that makes this subject feel significant. All of it emerged from the same cosmic history that ends in heat death. The universe produced something capable of comprehending its own emptiness, and that something is sitting in a room right now, feeling the floor beneath it, surrounded by objects that are mostly empty space, on a planet that is a speck in a solar system, that is a speck in a galaxy, that is a speck in a universe that is, by almost every measure, almost entirely nothing. This is not a poetic observation, it is a precise one. The capacity for awareness, for self-reflection, for the kind of abstract reasoning that allows a mind to trace the history of the cosmos and project its future, is, as far as we know, extraordinarily rare in the universe. We have found no evidence of it anywhere other than here. We have searched in limited ways and found silence. The universe is not teeming with minds. It may contain other minds somewhere in the vast structure of the cosmic web, on planets orbiting other stars and other galaxies. But if it does, those minds are separated from us by distances so enormous that communication between them may be practically impossible, and in the long run, given the accelerating expansion, literally impossible. Each island of awareness, if there are others, is alone in a way that has no human analog, not alone the way a person is alone in a room, alone the way a single candle is alone in a continent-sized darkness. The silence of the universe on the question of other minds is itself a kind of data. It is called the Fermi paradox, the observation that a universe as old and as large as ours, if it contained intelligent life in abundance, should by now have produced evidence of that life detectable from Earth. The universe is 13.8 billion years old. Stars similar to the Sun have existed for billions of years before the Sun formed. If intelligent life arises with any regularity around such stars, there has been ample time for civilizations to emerge, expand, and make their presence known across the galaxy. And yet we hear nothing. We see nothing. The sky is silent. The radio spectrum is empty of artificial signals. The galaxy shows no signs of large-scale engineering. The silence is not proof that we are alone. But it is consistent with a universe in which the emergence of awareness is not common, in which the islands of mind are few and far between, in which the emptiness between thinking things is as vast as the emptiness between stars. But it goes deeper, because even if we set aside the question of other minds, even if we focus only on what we know exists, the picture that emerges is one in which awareness is not just rare, but structurally marginal. The universe does not appear to have been arranged with awareness in mind. It does not appear to have been optimized for the production of complexity or consciousness or meaning. The conditions that allow for the existence of stars, planets, chemistry, and life occupy a tiny fraction of the universe's volume, a tiny fraction of its history, and a tiny fraction of its total energy budget. The vast majority of the universe, by volume, by mass, by energy, by time, is not hospitable to any of these things. It is cold, dark, empty, and expanding. The conditions we require are the exception. The void is the rule. This is not a new observation. Philosophers and scientists have noted for centuries that the universe appears indifferent to human existence. But the modern picture of cosmology makes this indifference more precise and more quantifiable than it has ever been before. It is not merely that the universe is large and we are small. It is that the universe is structured in a way that actively works against the persistence of the conditions that make complexity possible. The expansion carries galaxies beyond reach. Entropy dissolves structure. Star formation declines. The reservoir of usable energy depletes. The universe is not static and indifferent. It is dynamic and moving in a specific direction, and that direction is away from the conditions that support awareness, not toward them. Consider the cosmic web one more time, but now with this trajectory in mind. The filaments and nodes of the cosmic web represent the universe's current state of organization, the result of billions of years of gravitational assembly, of dark matter halos merging and growing, of gas cooling and condensing into galaxies, of galaxies clustering into groups and clusters and superclusters. It is, in a sense, the universe at its most organized, its most structured, its most complex, and it is already beginning to come apart. Not at the level of individual galaxies, which remain gravitationally bound, but at the level of the web itself. The accelerating expansion is stretching the filaments, pulling the clusters apart from one another, increasing the distances between the nodes. The web is not dissolving quickly, but it is dissolving. The structure that took billions of years to assemble is being undone by the same expansion that has been operating since the beginning, now accelerating under the influence of dark energy. There is a particular image that captures this process, not a photograph but a conceptual one. Imagine the cosmic web as a vast three-dimensional structure of luminous threads, each thread a filament of galaxies and dark matter, each node a cluster where multiple threads converge. Now imagine that structure slowly being stretched, the threads thinning, the nodes pulling apart, the distances between everything increasing. The threads do not break. The nodes do not explode. They simply move apart, slowly, continuously, until the threads are too thin to see and the nodes are too distant to detect. The web does not end. It fades. It becomes too sparse to be called a web. It becomes a collection of isolated points in an expanding void, each point a gravitationally bound island, each island surrounded by a darkness that grows larger with every passing moment. And within those islands, the same process of dissolution is occurring on smaller scales. Stars age and die. Gas is consumed. The stellar population of a galaxy shifts over time from the hot, bright, short-lived massive stars that dominate the early universe to the cooler, dimmer, longer-lived smaller stars that dominate the later universe. The galaxy becomes redder, dimmer, quieter. The rate of new star formation falls. The interstellar medium, the gas and dust between stars from which new stars are born, is gradually depleted. The galaxy does not explode or collapse. It simply ages. It becomes less active, less luminous, less capable of producing new complexity. It settles into a kind of cosmic senescence, a long, slow dimming that will eventually leave it populated only by the cooling remnants of stars that burned out long ago. The Milky Way is already in this process. The rate of star formation in our galaxy has been declining for billions of years. We are not in the peak era of galactic activity. We are in the declining phase, the long afternoon of a galaxy that was most productive in its youth. The Sun itself is a second or third generation star, formed from gas that had already been processed through earlier generations of stars. The heavy elements in your body, the carbon, the oxygen, the iron, the calcium, were forged in the cores of stars that lived and died before the Sun was born. You are, in a very literal sense, made of the remnants of dead stars, and the star that currently sustains life on Earth is itself middle-aged, burning through the second half of its hydrogen fuel, on a trajectory that will end in roughly 5 billion years with the expansion of the Sun into a red giant, the incineration of the inner planets, and the eventual collapse of the solar remnant into a white dwarf. 5 billion years is a long time by human standards. It is longer than the entire history of the Earth. It is long enough that it is difficult to feel as a threat, but it is not long by cosmic standards. It is a relatively short time in the multi-trillion-year story of the universe's stellar population, and it is a reminder that the conditions currently supporting life on Earth are not permanent. They are a phase, a window, a temporary alignment of circumstances that will not last indefinitely, and that exists against a backdrop of cosmic processes that are, on the whole, moving in the direction of dissolution rather than creation. But it gets worse, because the dissolution is not only physical, it is informational, and this is perhaps the most unsettling dimension of the emptiness, the one that is hardest to sit with, the one that the mind most wants to deflect or qualify or reframe as something less final than it appears. Information, in the physical sense, is not an abstract concept. It is a physical quantity. It is encoded in the arrangement of matter and energy. The information in a book is encoded in the arrangement of ink on paper. The information in a DNA molecule is encoded in the sequence of chemical bases along its length. The information in a memory is encoded in the pattern of synaptic connections in a brain. Information requires structure. It requires a physical substrate that maintains a particular arrangement over time, and structure, as we have seen, is not permanent. It is a temporary condition, a local reduction in entropy that is sustained only as long as the energy flows that maintain it continue to operate. When a star dies, the information encoded in its structure, the particular arrangement of its mass, the history of its nuclear reactions, the record of its formation and evolution, is not preserved. It is dispersed. The star's outer layers are blown into the interstellar medium, mixed with other gas, diluted and randomized. The stellar remnant retains some information about the star's mass and rotation, but the detailed history is gone. When a planet is destroyed, the information encoded in its geology, its chemistry, its atmospheric history is dispersed. When a civilization ends, the information encoded in its culture, its knowledge, its accumulated understanding of the universe is dispersed, unless it has been transmitted somewhere that survives. And in the long run, in the run that ends in heat death, nothing survives. Every record is eventually erased. Every memory is eventually lost. Every trace of every event that ever occurred in the history of the universe is eventually dissolved into the featureless thermal equilibrium of maximum entropy. This is not a metaphor. It is a physical prediction. The second law of thermodynamics does not make exceptions for significance. It does not preserve the records of important events while erasing trivial ones. It erases everything with equal indifference. The formation of the first stars, the emergence of the first life, the first moment a mind looked up at the sky and wondered what it was looking at. All of these events will leave no trace in the final state of the universe, not because they were unimportant, but because importance is not a physical quantity. It is a concept that exists only in the presence of minds capable of assigning it. And minds, like everything else, are temporary. There is a thought experiment that physicists sometimes use to illustrate the relationship between entropy and information, and it goes something like this. Imagine a glass of water with a drop of ink placed carefully at its center. At the moment of placement, the ink is concentrated, ordered, distinct. Its position carries information. You can look at the glass and see that the ink is there, in that particular place, in that particular concentration. Now wait. The ink diffuses. The molecules of ink spread through the water, driven by thermal motion, moving from regions of higher concentration to regions of lower concentration. After a few minutes, the ink is uniformly distributed through the water. The glass is a uniform pale blue. The information about the initial position of the ink is gone, not destroyed in any dramatic sense, simply dispersed. The molecules are still there, but their arrangement no longer carries the information it once did. The entropy has increased, the order has dissolved into disorder, and there is no process, no intervention, no amount of waiting that will spontaneously reverse this. The ink will not reconcentrate, the information will not return. The universe is the glass of water. The stars and galaxies and planets and minds are the drop of ink. And the heat death is the moment when the ink has fully diffused, when the universe has reached its uniform pale blue, when every concentration of order has dissolved into the background, and the information encoded in all of it is gone. This is not a poetic analogy. It is a precise one. The physics of entropy applies to the universe as a whole in exactly the same way it applies to the glass of water, scaled up by factors that strain comprehension, but governed by the same fundamental laws. And yet, sitting here, in this room, on this planet, in this moment, the ink has not yet diffused. The drop is still there. The concentration is still visible. The stars are still burning. The galaxies are still assembling. The cosmic web is still intact, if slowly stretching. Life exists, at least here, and possibly elsewhere. Minds exist, at least here, capable of tracing the history of the cosmos and projecting its future. The window is open. The conditions are present. The entropy has not yet won, but this is not reassurance. It is context. The fact that the window is currently open does not mean it will remain open. The fact that the conditions are currently present does not mean they are permanent. The fact that the entropy has not yet won does not mean it will not win. It means only that we are early in the process, that the universe is still in the phase where the drop of ink is visible, where the concentration of order is still high enough to support the kind of complexity that can look at itself and ask questions. We are not at the beginning of this process. We are somewhere in the middle, perhaps past the middle, in a universe that has already spent a significant fraction of its low entropy budget and will spend the rest over timescales that dwarf anything in human experience. The middle is not a comfortable place to be when you understand the direction of travel. It is not the same as being at the beginning, when the future is open and the possibilities are many. It is not the same as being at the end when the process is complete and there is nothing left to lose. The middle is the place where you can see both directions, where you can look back at the formation of the first stars and forward to the evaporation of the last black holes, where you can appreciate the extraordinary improbability of the current moment, the fact that the universe has produced In this particular corner of a particular galaxy, the conditions for awareness and inquiry, while also understanding that this moment is not the destination, it is a waypoint, a temporary eddy in a river that flows in one direction, and the direction is toward emptiness, not the emptiness of the void between galaxies, though that emptiness will grow, not the emptiness inside atoms, though that emptiness will persist until the atoms themselves decay, but a deeper emptiness, the emptiness of a universe that has exhausted its capacity for structure, for complexity, for the kind of organized low-entropy arrangements that make events possible. An emptiness that is not merely spatial, but temporal, not just the absence of things in space, but the absence of change in time. A universe in which nothing new can happen, not because everything has been forbidden, but because everything has been spent. This is the trajectory that the physics describes, and it is worth being honest about what it means to follow that trajectory to its conclusion. It means that the universe, for all its current richness, for all the extraordinary complexity that has emerged from the initial conditions of the Big Bang, is not building toward something. It is not progressing toward a state of greater organization, greater complexity, greater awareness. It is moving in the opposite direction. The complexity we observe is not the universe's destination. It is a byproduct of the universe spending its low-entropy budget, a temporary efflorescence of order that arises in the middle of a process whose beginning and end are both characterized by the absence of the conditions that make complexity possible. The Big Bang produced a universe of extraordinary low entropy, but it was not a universe of complexity. It was a universe of hot, dense, nearly uniform plasma, with tiny fluctuations that would eventually seed the formation of structure. The heat death will produce a universe of maximum entropy, and it too will not be a universe of complexity. It will be a universe of cold, thin, nearly uniform radiation, with no fluctuations capable of seeding anything. The complexity, the stars and galaxies and planets and minds exists in the middle, in the long transition between these two states of near uniformity. It is the foam on the surface of a wave, beautiful and intricate and real, but not the wave itself. The wave was always moving in one direction. The foam was always temporary. There is something in this picture that resists easy categorization as either tragic or neutral. It is not tragic in the way that a premature death is tragic, because the universe is not being cut short. It is completing a process that was always going to complete. It is not neutral in the way that a mathematical theorem is neutral, because the process involves the dissolution of everything that has ever mattered to anything capable of mattering. It occupies a strange space between these categories, a space that human language and human emotional vocabulary were not designed to navigate, because human language and human emotional vocabulary evolved to deal with human-scale events, not with the thermodynamic fate of the cosmos. And perhaps this is the most honest thing that can be said about the emptiness of the universe. It does not fit neatly into any of the frameworks we use to make sense of things. It is not a problem to be solved. It is not a mystery to be unraveled. It is not a tragedy to be mourned or a fact to be accepted with equanimity. It is simply what the universe is, and what the universe is doing, described as accurately as the current state of physics allows. The emptiness is not a backdrop, it is not a setting, it is not the space between the important things. It is the dominant feature of the universe at every scale we can examine, from the interior of atoms to the structure of the cosmic web, from the current moment to the heat death, from the visible matter to the dark energy that fills all of space. And the things we call important, the stars, the galaxies, the planets, the minds, are not interruptions in the emptiness, they are expressions of it. They are what happens when the emptiness is briefly, locally, temporarily organized by the laws of physics into structures capable of complexity. They are the drop of ink in the glass of water, visible and distinct and real, but already in the process of diffusing, already moving toward the uniform pale blue that is the emptiness's final form. But there is one more layer to this picture that has not yet been fully examined, one more dimension of the emptiness that goes beyond the physical and into something that is harder to name but impossible to ignore once you have seen it. It is the question of what the emptiness means for the relationship between the universe and the minds it has produced, not in a spiritual sense, not in a theological sense, but in a purely physical, structural sense. What does it mean that the universe has produced minds capable of understanding its own emptiness, and that those minds exist in a universe that is, by every measure, indifferent to their existence and moving in a direction that will eventually make their existence impossible? This is not a new question. It has been asked in various forms by philosophers and scientists for as long as humans have been capable of asking it. But the modern cosmological picture gives it a precision and a weight that earlier formulations lacked. Because earlier formulations were working with a universe of uncertain size and uncertain age and uncertain fate. The modern picture is working with a universe whose size, age, composition, and trajectory are known with remarkable precision. And the precision makes the question harder to deflect. It is not possible to say that the universe might be different from what it appears, that there might be hidden dimensions of meaning that the physics has not yet revealed. The physics has been tested to extraordinary precision. The expansion is real. The acceleration is real. The dark energy is real. The entropy is real. The heat death is, as far as we can determine, the actual fate of the actual universe we actually inhabit. And the minds that have determined this, the physicists and astronomers and cosmologists who have spent their careers measuring the universe and building the models that describe it, are themselves made of the matter that will eventually decay, living on a planet that will eventually be incinerated, in a galaxy that will eventually go dark, in a universe that is moving inexorably toward a state in which none of this will have left any trace. The knowledge they have produced, the understanding of the universe that humanity has accumulated over centuries of observation and experiment and theory, is itself subject to the same entropy that governs everything else. It exists in physical substrates, in books and databases and the neural patterns of living minds, and those substrates are not permanent. The knowledge is real, but it is not eternal. Nothing is. This is the view from the middle of the wave. This is what it looks like to be a temporary concentration of low entropy, in a universe that is moving toward maximum entropy. It looks like a room with solid walls and a floor that holds your weight. It looks like a sky full of stars. It looks like a cosmos of extraordinary richness and complexity. And it is all of those things. But it is also a temporary condition, a phase, a window that is open now and will not always be open. A drop of ink that is still visible but is already diffusing into the pale blue of the final state. The emptiness was always the majority. It was the majority inside the atoms of the floor beneath you. It was the majority in the solar system, in the space between planets and between stars. It was the majority in the galaxy, in the vast dark distances between the points of light. It was the majority in the universe, in the cosmic voids that dwarf the filaments of the cosmic web. And it is the majority in time, in the long stretches before the first stars and after the last black holes, during which the conditions for complexity do not exist. The era of stars, the era of galaxies, the era of minds, is a brief interval in a much longer story whose dominant theme is not light but darkness, not structure but dissolution, not presence but absence. There is a particular kind of vertigo that comes from holding two things in mind simultaneously. The first is the immediate reality of your experience, the weight of your body, the texture of the air, the ordinary persistence of the world around you. The second is the cosmological reality, the near-total emptiness of matter, the vast, dark distances between stars, the accelerating expansion carrying galaxies beyond reach, the entropy slowly dissolving every structure the universe has ever produced. These two realities do not cancel each other out. They coexist. And the vertigo comes from the fact that both are true at the same time in the same universe in the same moment. The floor is solid and the floor is mostly empty space. The sky is full of stars and the stars are vanishingly rare points in an ocean of darkness. The universe is rich with structure, and the structure is a temporary exception in a cosmos whose dominant condition is absence. This coexistence is not a paradox to be resolved. It is a feature of the universe that scale-dependent descriptions are genuinely different from one another, without either being wrong. At the scale of human experience, the world is solid, continuous, and full of things. At the scale of atoms, it is mostly empty space governed by electromagnetic forces. At the scale of the solar system, it is a handful of objects separated by enormous distances of vacuum. At the scale of the galaxy, it is a sparse arrangement of stars in a vast dark volume. At the scale of the universe, it is a thin web of matter surrounded by enormous voids, all of it embedded in a sea of dark energy that is slowly pulling everything apart. Each description is accurate at its scale, and the scales do not average out into something comfortable. They stack. Each one reveals a deeper and more pervasive emptiness than the one before it, and there is one more scale that has not yet been fully examined. A scale that is in some ways the most disturbing of all, not because it is the largest, but because it is the most intimate. It is the scale of time, not the time scale of human life, or of civilizations, or even of the earth. The time scale of the universe itself, from its beginning to its end, and what that time scale reveals about the place of the current moment within the larger story. The universe is approximately 13.8 billion years old. The first stars formed roughly 200 million years after the Big Bang. The Sun formed about 4.5 billion years ago. Life on Earth has existed for roughly 3.5 billion years. Complex, multicellular life has existed for perhaps 600 million years. Anatomically, modern humans have existed for roughly 300,000 years. Recorded human history spans about 5,000 years. The entire span of human civilization, from the first cities to the present moment, is less than 1/10,000,000th of the current age of the universe. Now extend the timeline forward. The Sun has roughly 5 billion years of hydrogen fuel remaining. The last red dwarf stars will burn for perhaps 10 trillion years. The era of star formation will effectively end within a few trillion years. White dwarfs will cool over quadrillions of years. If proton decay occurs, ordinary matter will dissolve over timescales of at least 10 to the 34th years. Stellar mass black holes will evaporate via Hawking radiation over timescales of around 10 to the 67th years. Supermassive black holes will take far longer, perhaps 10 to the 100th years or more. And after the last black hole evaporates, the universe will continue to expand and cool for a duration that has no meaningful upper bound. A duration that is, for all practical purposes, infinite. Place the current moment on this timeline. The universe is 13.8 billion years old. The total duration of the stelliferous era, the era of stars, is perhaps 10 to 100 trillion years. We are currently in the first fraction of a percent of the stelliferous era. And the stelliferous era is itself a tiny fraction of the total timeline of the universe, which extends through the degenerate era of cooling white dwarfs, through the black hole era, and into the dark era that follows the evaporation of the last black hole, a dark era whose duration dwarfs all preceding eras combined by factors that make the word vast feel inadequate. The current moment, the moment in which stars burn and galaxies exist and life is possible, and minds can ask questions about the universe, is not the middle of the universe's story. It is the very beginning. We are in the opening pages of a book whose total length is effectively infinite, and the opening pages are the only ones that contain anything resembling the conditions we associate with a living universe. The rest of the book, the overwhelming majority of it, is the story of a universe growing darker, colder, emptier, and less capable of producing anything new. The opening pages are extraordinary, but they are the opening pages. And the universe does not care about the opening pages any more than it cares about the rest. This temporal emptiness is perhaps the hardest dimension of the cosmic picture to absorb. Spatial emptiness can be visualized, at least approximately. You can imagine the vast dark distances between stars, the enormous voids between galaxy clusters, the expanding space carrying galaxies beyond the horizon. These are spatial concepts, and the human mind has some capacity for spatial imagination, even at scales far beyond ordinary experience. But temporal emptiness, the emptiness of a future that extends for durations so vast that the entire history of the universe to date is a rounding error, is not something the mind can visualize. It can only be stated. And the statement is this: the conditions that currently exist, the conditions that allow for stars and planets and life and minds, occupy an infinitesimally small fraction of the total duration of the universe. Everything we know, everything we are, everything we have ever imagined or built or understood, exists in a sliver of time so thin that it would be invisible on any honest timeline of the cosmos. But it goes deeper. Because the temporal emptiness is not merely a matter of duration, it is a matter of direction. The universe is not cycling. It is not oscillating between states of high and low entropy, returning periodically to the conditions that allow for complexity. As far as current physics can determine, the universe moves in one direction in time, from lower entropy to higher entropy, from the concentrated order of the Big Bang toward the diffuse disorder of the heat death. There is no return. There is no reset. The conditions that currently exist will not recur. The stars that are burning now will not burn again. The galaxies that are assembling now will not reassemble. The minds that are thinking now will not think again, not in any form that preserves continuity with the present. This is not a certainty. Physics at the frontier is always provisional. There are speculative ideas, some of them mathematically serious, that suggest the possibility of new universes emerging from the quantum vacuum, or of cyclic cosmologies in which the universe undergoes repeated expansions and contractions, or of a multiverse in which the conditions we observe are just one of an enormous number of possible configurations. These ideas are real areas of scientific inquiry. They are not fringe speculation, but they are also not established fact. They are possibilities, some of them mathematically motivated, none of them empirically confirmed, and even if some version of them is correct, they do not change the trajectory of this universe, the one we actually inhabit. This universe is moving toward heat death. Whatever may or may not happen in other universes or in whatever comes after this one does not alter the fate of the structure we are part of. And there is something important about sitting with that, about not immediately reaching for the escape hatch of the multiverse or the cyclic cosmology or any other framework that softens the conclusion, because the softening is a form of avoidance. It is the mind doing what it always does when confronted with something it cannot comfortably accommodate, reaching for a way out. And the way out, in this case, is not supported by evidence. It is supported by the desire for the universe to be different from what it appears to be. That desire is understandable, it is human, but it is not physics. The physics says this. The universe began in a state of extraordinarily low entropy. It has been increasing in entropy ever since. The structures we observe, the stars, the galaxies, the planets, the minds, are temporary local reductions in entropy sustained by the flow of energy from high entropy sources to low entropy sinks. That flow will eventually cease. The entropy will reach its maximum. The structures will dissolve. The information encoded in them will be dispersed, and the universe will continue to exist in a state of maximum entropy for a duration that is effectively infinite, containing nothing capable of observing it, nothing capable of recording it, nothing capable of caring about it in any sense we understand. Now, return to the room. Return to the floor beneath you, the walls around you, the objects in the ordinary geometry of your daily life. They are still there. The floor still holds your weight, the walls still stand, the objects still maintain their shapes. Nothing has changed in the room, but something has changed in the way the room can be seen, because the room is not just a room. It is a temporary arrangement of matter in a universe that is mostly empty space, on a planet that is a speck in a solar system that is a speck in a galaxy, that is a speck in a universe that is, by almost every measure, almost entirely nothing, and the arrangement is temporary. The matter will not always be arranged this way. The planet will not always exist. The galaxy will not always shine. The universe will not always contain the conditions that make rooms possible. The room is real. The floor is real. The objects are real. But their reality is a borrowed reality, borrowed from the low entropy budget of the universe, sustained by the ongoing flow of energy from the sun, maintained by the electromagnetic forces that make matter feel solid, and subject to the same thermodynamic fate as everything else. The room is not a permanent feature of the universe. It is a temporary eddy of order in a cosmos that is moving toward disorder. It is the drop of ink, still visible, still distinct, still real, but already diffusing, and this is where the emptiness becomes something more than a scientific fact. It becomes a condition, a pervasive structural condition that underlies everything we experience and everything we can imagine. Not a condition that negates experience or makes it meaningless in any simple sense, but a condition that frames it, that places it in a context so vast and so indifferent that the frameworks we normally use to assign meaning, the frameworks of human history, of cultural significance, of personal narrative, become very small against the background. The background is not hostile, it is not malevolent, it does not wish anything, it does not intend anything. It simply is what it is, an expanding, cooling, darkening cosmos in which the conditions for complexity exist briefly and locally, and in which those conditions are not the destination, but the exception. The background is the emptiness, and the emptiness is not waiting for anything, it is not building toward anything. It is simply the state toward which the universe is moving, the state it has been moving toward since the beginning, the state it will eventually reach and then maintain, without variation, without event, without observation, for a duration that has no meaningful end. There is a concept in thermodynamics called the arrow of time, the observation that time appears to have a direction, that the past is different from the future, that entropy increases rather than decreases, that the universe moves from order to disorder rather than the reverse. The arrow of time is not a law in the same sense as the conservation of energy. It is an emergent property of the universe's initial conditions. The laws of physics at the microscopic level are, for the most part, time-symmetric. They work the same way forward and backward, but the universe began in a state of extraordinarily low entropy, and that initial condition gives time its direction. The arrow points from the low entropy past toward the high entropy future. It points from the Big Bang toward the heat death. It points, in other words, from the beginning of structure toward the end of structure, from the beginning of complexity toward the end of complexity, from the beginning of the conditions that make awareness possible toward the end of those conditions. The arrow of time is the arrow of emptiness. It points toward the void, not the void of space, though that void will grow, but the void of possibility, the void of event, the void of change. The arrow points toward a universe in which nothing new can happen, in which the past is not merely gone but unrecoverable, in which the future is not merely uncertain but empty. And everything we experience, every moment of awareness, every thought, every perception, every sensation of the floor beneath your feet and the air in your lungs, is located on this arrow, somewhere between the low entropy beginning and the high entropy end, moving in one direction, at 1 second per second, toward the void. But it gets worse, because the arrow of time is not just a feature of the universe's large-scale thermodynamics. It is a feature of every process within the universe. Every chemical reaction, every biological process, every neural event, every thought, is an irreversible process that increases entropy. The act of thinking, the electrochemical cascade that constitutes a moment of awareness, is itself an entropy-increasing process. The brain is a thermodynamic machine. It takes in low-entropy energy in the form of glucose and oxygen and produces high-entropy waste in the form of heat and carbon dioxide. Every thought you have is a small contribution to the universe's entropy budget. Every moment of awareness is a small step along the arrow of time in the direction of the void. This is not a reason to stop thinking. It is not a reason to despair in any simple sense. It is simply a description of what thinking is at the physical level. Thinking is a process that occurs within the universe, subject to the same laws as everything else in the universe, moving in the same direction as everything else in the universe. The mind is not exempt from thermodynamics. Awareness is not exempt from entropy. The capacity for wonder and dread and inquiry that makes this subject feel significant is itself a thermodynamic process, burning through the low entropy budget of the universe, contributing to the entropy that will eventually make awareness impossible. There is something almost unbearably recursive about this. The mind that is trying to understand the emptiness of the universe is itself a temporary structure in that universe, subject to the same dissolution it is trying to comprehend. The understanding is real, the comprehension is genuine, but it is happening in a substrate that will not last, in a universe that will not preserve it, in a cosmos that will eventually reach a state in which the fact that this understanding ever existed will leave no trace. The knowledge is real and the knowledge is temporary, and both of these things are true at the same time, in the same mind, in the same moment. And yet the moment exists, the understanding exists, the awareness exists. Whatever the universe's ultimate trajectory, whatever the thermodynamic fate of every structure within it, the current moment is real. The experience of sitting in a room and following a chain of reasoning from the solidity of the floor to the heat death of the universe is a real event. It is happening. It is, in the most literal sense, a part of the universe's history, a part of the record of what has occurred in this particular corner of the cosmos during this particular phase of its evolution. The record will not be preserved, but the event is real. This is not comfort. It is not meant to be comfort. It is simply precision. The emptiness of the universe does not negate the reality of the current moment. It contextualizes it. It places it in a frame so large that the frame itself becomes the dominant feature of the picture, and the dominant feature of the frame is absence. The dominant feature of the universe, at every scale and across all of time, is the absence of the conditions that make moments like this one possible. The moments are real, but they are rare, they are brief, they are local, and they are temporary in a way that the emptiness is not. Consider the night sky one final time, not as a source of wonder, though it is that, not as a map of the cosmos, though it is that too. Consider it as a record of distances and times, as a physical document of the universe's structure and history. Every point of light in the night sky is a star or a galaxy, and every one of them is separated from you by a distance so large that the light you are seeing left its source long before you were born, long before the Earth existed in its current form, in some cases long before the solar system formed. The night sky is not a view of the present, it is a view of the past, assembled from light that has been traveling toward you for years, centuries, millennia, millions of years, billions of years. And the distances that light has crossed to reach you are not empty in the simple sense. They are filled with the expanding fabric of space-time, threaded with dark matter and dark energy, crossed by gravitational waves from colliding black holes and neutron stars, permeated by the cosmic microwave background, the faint thermal afterglow of the Big Bang itself, now cooled to just a few degrees above absolute zero, filling all of space uniformly. the most pervasive and most ancient light in the universe. The space between the stars is not nothing, but it is not the kind of something that supports complexity. It is the kind of something that dilutes it, disperses it, carries it away from any concentration that might sustain structure. The cosmic microwave background is worth pausing on, because it is one of the most extraordinary things in the universe and one of the least appreciated. It is light, real electromagnetic radiation, photons traveling through space. But it is light from the early universe, from a time roughly 380,000 years after the Big Bang, when the universe had cooled enough for electrons and protons to combine into neutral hydrogen atoms, allowing light to travel freely for the first time. Before that moment, the universe was opaque, a hot, dense plasma through which light could not propagate. After that moment, the light was released, and it has been traveling ever since, filling all of space, cooling as the universe expands. Its wavelength stretched from the visible range into the microwave range by 13.8 billion years of cosmic expansion. When you look at the night sky, you are not seeing the cosmic microwave background. It is invisible to the naked eye, its wavelength far too long for human vision, but it is there. It fills the space between every star you can see, between every galaxy, between every void. It is the most uniform thing in the universe, varying in temperature by only about 1 part in 100,000 across the entire sky. It is the universe's oldest light, and it is everywhere, and it is cold, and it is fading. As the universe continues to expand, the wavelength of the cosmic microwave background will continue to stretch. Its temperature will continue to fall. Eventually, in the far future, it will be so cold and so long wavelength that it will be effectively undetectable, even in principle. The universe's oldest light will fade into the background of the expanding void, indistinguishable from the quantum noise of empty space. This fading is a small thing in the context of the universe's total energy budget. The cosmic microwave background carries very little energy compared to the stars and galaxies, but it is symbolically significant in the way that the last light of a dying fire is symbolically significant. It is the universe's memory of its own beginning, the faint thermal echo of the moment when light first traveled freely through space, and it is fading. Everything is fading. The stars are burning through their fuel. The galaxies are aging. The cosmic web is stretching. The horizon is shrinking. The entropy is increasing. Everything is moving in the same direction, at different rates, toward the same destination. And the destination is not a place. It is a condition of maximum entropy, of minimum structure, of zero capacity for event or change or observation. A condition that is, in the most precise physical sense, the absence of everything that makes the universe interesting, not the absence of the universe itself. The universe will still exist, in a sense. The space-time will still be there, expanding. The dark energy will still be there, driving the expansion. The photons and neutrinos and whatever remains after the evaporation of the last black holes will still be there, thinning and cooling in the expanding void. But none of it will be organized. None of it will be structured. None of it will be capable of producing anything new. The universe will be present and empty at the same time, in the way that a room is present after everything in it has been removed. The room is still there, but the room is empty. The room is still there, but the room is empty. This is the universe's final condition, stated as simply as it can be stated, and the path from the current moment to that condition is not a mystery. It is not hidden. It is written in the laws of thermodynamics, in the measurements of the expansion rate, in the observations of the cosmic web and the cosmic microwave background, and the rotation curves of galaxies, and the redshifts of distant supernovae. The path is clear. The destination is clear. The only thing that is not clear is the exact timeline, the precise sequence of events between now and the heat death, the details of how the last stars will die and how the last black holes will evaporate and what, if anything, will be left to observe any of it. But the broad outline is not in doubt. The universe is moving toward emptiness. It has always been moving toward emptiness. The emptiness was always the majority, and it is becoming more so with every passing moment, as the expansion carries galaxies beyond the horizon, as the stars burn through their fuel, as the entropy increases, as the structures dissolve. The universe is not becoming full, it is becoming empty. And the things that currently interrupt the emptiness, the stars, the galaxies, the planets, the minds, are not the universe's destination. They are its current phase, a phase that is, by cosmic standards, already well advanced in its decline. This is the view from the middle of the wave. This is what the universe looks like when you follow the physics honestly, without softening the conclusions, without reaching for reassurance, without allowing the desire for meaning to distort the description of what is actually there. The universe is vast and mostly empty, and getting emptier. The matter within it is a small fraction of the total energy budget, and most of that matter is dark and invisible. The visible matter, the stars and galaxies and everything we have ever observed, is a tiny fraction of a small fraction. The conditions that allow for complexity and awareness are temporary and local. The trajectory of the universe is toward a state in which those conditions no longer exist. And the timescale of that trajectory is so long that the entire history of the universe to date, including the entire history of life and mind on Earth, is a rounding error. And yet here you are, in a room, on a planet, in a galaxy, in a universe that is mostly empty and getting emptier, aware of it, capable of tracing the history of the cosmos from the Big Bang to the heat death, capable of feeling the vertigo of the scale, the unease of the trajectory, the strange recursive quality of a mind comprehending its own thermodynamic fate. The awareness is real, the comprehension is real, the unease is real, and all of it is happening in a universe that does not require any of it. That would be exactly what it is, whether or not any mind had ever arisen to observe it, that is moving toward a state in which no mind will ever arise again. The emptiness does not need you to understand it. It does not need you to feel it. It does not need you to be disturbed by it. It simply is what it is, the dominant condition of the universe at every scale, the direction of the universe's evolution, the final state toward which everything is moving. It was there before the first star ignited. It will be there after the last black hole evaporates. It surrounds every atom in your body and every galaxy in the observable universe. It is not the background. It is not the space between things. It is the majority. It was always the majority. And the things we call the universe, the stars and galaxies and planets and minds, are not the universe. They are what the universe briefly, locally, temporarily does with a small fraction of its low entropy budget before returning to the emptiness that was always its dominant condition. The floor beneath you is still solid. The walls still stand. The objects in the room still maintain their shapes. Nothing has changed, and everything has changed, because the room is not what it appeared to be at the beginning of this journey. It is not a solid structure in a universe full of things. It is a temporary arrangement of mostly empty matter in a universe that is almost entirely empty, on a trajectory toward a state of complete and permanent emptiness, sustained for now by the ongoing flow of energy from a star that is burning through its fuel, on a planet that will not always exist, in a galaxy that will not always shine, in a universe that will not always contain the conditions that make rooms possible. There is a particular quality to the silence between stars that is different from any silence you have ever experienced. The silence in a quiet room is the absence of sound waves in air. It is a local condition, bounded by walls, temporary, easily broken. The silence between stars is something else entirely. It is not the absence of sound in a medium. It is the absence of the medium itself. Space does not carry sound. There is no air, no water, no material of any kind through which pressure waves can propagate. The silence between stars is not a quiet version of the silence you know. It is a categorically different condition, a condition in which the concept of sound has no meaning, in which the vibrations that constitute noise cannot exist, in which the universe is not merely quiet, but structurally incapable of being loud. This distinction matters because it points to something important about the nature of the emptiness. The emptiness of space is not simply the absence of familiar things. It is the absence of the conditions that make familiar things possible. Sound requires a medium. Life, as we know it, requires liquid water and chemical gradients and a stable energy source. Complexity requires low entropy and the flow of energy from concentrated sources to diffuse sinks. Awareness requires a physical substrate capable of storing and processing information. None of these requirements are met in the vast majority of the universe. The emptiness is not just empty of things. It is empty of the preconditions for things. It is a condition in which the universe has not merely failed to produce complexity, but has actively removed the scaffolding that complexity requires, and the scaffolding is being removed more thoroughly with every passing moment. The expansion of the universe is not merely increasing the distances between galaxies, it is diluting the density of matter and energy throughout space. As the universe expands, the same amount of matter and energy is spread across a larger and larger volume. The average density of the universe decreases. The average temperature decreases. The average energy density decreases. The universe is not just getting bigger, it is getting thinner. And a thinner universe is a universe in which the conditions for complexity are harder to maintain, in which the concentrations of matter and energy that support stars and planets and life are increasingly rare against the background of the expanding void. Consider what this means for the long-term future of any civilization that might exist anywhere in the universe, not just humanity, but any form of organized complexity capable of persisting over cosmic timescales. Such a civilization would face a universe that is progressively less hospitable, not because of any catastrophe or external threat, but simply because of the direction in which the universe is moving. The stars that provide energy would age and die. The gas that forms new stars would be depleted. The galaxies that provide the gravitational scaffolding for planetary systems would age and dim. The cosmic horizon would shrink, cutting off access to resources and information from increasingly large regions of space. And the entropy would increase, making every process less efficient, every structure less stable, every computation more costly in terms of the energy required to perform it. The physicist Freeman Dyson explored some of these questions in a famous 1979 paper on the long-term future of the universe, asking whether life and intelligence could persist indefinitely in an expanding, cooling cosmos. His analysis was ingenious and, in its way, hopeful, suggesting that by slowing down the rate of thought and computation, by hibernating for increasingly long periods between moments of activity, a sufficiently adaptable form of intelligence might be able to persist for an effectively infinite time, spending less and less energy per thought as the universe cooled, always staying just ahead of the thermodynamic limits. It was a remarkable piece of reasoning, and it captured something important about the relationship between intelligence and physics. But subsequent analysis complicated the picture. The accelerating expansion of the universe, which was not known when Dyson wrote his paper, changes the calculations significantly. In an accelerating universe, the cosmological horizon shrinks over time, cutting off access to energy sources and information from increasingly large regions of space. The amount of energy available to any civilization, no matter how efficient, is not infinite. It is bounded by the horizon, and as the horizon shrinks, the bound decreases. The accelerating expansion does not merely make the universe emptier, it makes it finite in a new and more fundamental sense. Finite not just in the amount of matter it contains, but in the amount of accessible energy it will ever make available to any observer within it. This is a result that even Dyson acknowledged would require a fundamental revision of his earlier optimism. In an accelerating universe, the long-term future of intelligence is not a story of indefinite persistence through increasing efficiency. It is a story of a finite total experience, a bounded sum of all possible thoughts and observations and computations, after which the energy runs out and nothing more is possible. The universe does not merely end in heat death. It ends in a heat death that was always coming, that was built into the geometry of the accelerating expansion from the moment dark energy began to dominate, that set a finite limit on the total amount of complexity the universe would ever produce. And this finite limit applies not just to the future but to the past and present as well. The total amount of complexity that has ever existed in the universe, all the stars that have ever burned, all the planets that have ever formed, all the life that has ever lived, all the thoughts that have ever been thought, is a finite quantity. It is an extraordinarily large finite quantity, larger than any number that has ever been written down in the history of human mathematics. But it is finite. The universe has a complexity budget, and it is being spent. Every star that burns is spending it. Every thought that is thought is spending it. And when it is spent, there will be no more, not because the universe will end, but because the universe will have exhausted the conditions that make complexity possible, and will continue to exist in a state of maximum entropy for a duration that dwarfs the entire history of complexity by factors that have no meaningful name. But it goes deeper. Because the finite complexity budget of the universe is not distributed evenly across time, the overwhelming majority of the universe's complexity has been produced in a relatively narrow window of cosmic history, the stelliferous era, the era of stars, the era we are currently in. Before the first stars formed, the universe was a nearly uniform plasma, then a nearly uniform gas, with no stars, no planets, no chemistry beyond the simplest elements, no conditions for life. After the last stars die, the universe will be a collection of cooling remnants in an expanding void, with no energy flows capable of sustaining complexity. The window of complexity is bounded on both sides by conditions of near total simplicity, and we are inside that window right now in this moment, which is why the room feels solid and the sky is full of stars, and the mind can ask questions about the universe. The window is open, but it is not always open, and it will not always be open. The window opened when the first stars ignited, hundreds of millions of years after the Big Bang. It will close when the last red dwarfs exhaust their fuel, trillions of years from now. Between those two moments, the universe is capable of producing and sustaining complexity. Outside those moments, it is not. And the duration of the window, vast as it is by human standards, is a tiny fraction of the total duration of the universe. The window is a brief interruption in a much longer story of simplicity and emptiness. This is the temporal version of the spatial picture we have been building throughout this journey. Just as the matter in the universe occupies only a tiny fraction of the total volume, concentrated in the thin filaments and nodes of the cosmic web, while the vast majority of space is void, the complexity in the universe occupies only a tiny fraction of the total duration, concentrated in the stelliferous era, while the vast majority of time is either pre-stellar simplicity or post-stellar emptiness. The universe is not mostly complex. It is mostly simple. It is mostly empty. It is mostly dark. And the brief, extraordinary window of complexity that we inhabit is not the universe's purpose or destination. It is an accident of initial conditions, a consequence of the particular low-entropy state in which the universe began, playing out according to the laws of thermodynamics in the only direction those laws permit. And yet, within that window, something remarkable has happened. Not remarkable in the sense of being cosmically significant, because the cosmos does not assign significance, but remarkable in the sense of being extraordinarily improbable, extraordinarily intricate, extraordinarily unlike the conditions that surround it on all sides in space and time. Within the window, in this particular corner of a particular galaxy, on a small, rocky planet orbiting an unremarkable star, the matter of the universe has organized itself into structures capable of asking questions about the universe. Structures capable of measuring the expansion rate, mapping the cosmic web, detecting the cosmic microwave background, calculating the timescale of proton decay, and tracing the trajectory of the universe from its low-entropy beginning to its high-entropy end. This is not a small thing. It is, in fact, one of the most extraordinary things that the laws of physics permit. The universe has produced, within the window of complexity, structures that can model the universe itself. Structures that can hold the entire cosmic history in their minds, from the Big Bang to the heat death, and examine it, and describe it, and feel something about it. The feeling is real, the examination is real, the description is real, and all of it is happening in a substrate made of atoms that are mostly empty space, on a planet that is a speck in a solar system, that is a speck in a galaxy, that is a speck in a universe that is, by almost every measure, almost entirely nothing. The contrast is not lost. It is, in fact, the sharpest edge of the entire picture. The universe is almost entirely empty, and within that emptiness, in a vanishingly small region of space and a vanishingly small window of time, it has produced something capable of comprehending its own emptiness. The comprehension does not fill the emptiness. It does not change the trajectory. It does not alter the thermodynamic fate. But it is real. It is happening. And it is, in the most literal sense, the universe looking at itself. But what does the universe see when it looks at itself through the lens of a human mind? It sees the floor beneath your feet, which is mostly empty space. It sees the solar system, which is mostly vacuum. It sees the galaxy, which is mostly darkness. It sees the cosmic web, which is mostly void. It sees the expansion, which is accelerating. It sees the entropy, which is increasing. It sees the horizon, which is shrinking. It sees the stars, which are aging. It sees the future, which is dark. And it sees the present moment, which is extraordinary and temporary and real. The present moment is extraordinary not because it is comfortable or reassuring or because it suggests that everything will be fine. It is extraordinary because it exists at all. Because the conditions that make it possible are so specific, so improbable, so narrowly bounded in space and time, that their existence is genuinely remarkable against the background of the universe's dominant condition of emptiness. The present moment is a fluctuation, a local, temporary, improbable fluctuation in a universe that is, on the whole, moving away from the conditions that make such fluctuations possible, and fluctuations end. This is not a metaphor. It is a physical description. A fluctuation is a temporary departure from equilibrium. It arises when local conditions permit a reduction in entropy, sustained by the flow of energy from a concentrated source. It persists as long as the energy flow continues, and it ends when the energy flow stops, when the source is exhausted, when the conditions that sustained it are no longer present. The fluctuation does not fight its ending. It does not resist the return to equilibrium. It simply ends, the way a wave ends when it reaches the shore, the way a fire ends when the fuel is consumed, the way a star ends when the hydrogen is gone. The universe is full of endings, not dramatic endings for the most part, not explosions or collapses or singular moments of catastrophe, quiet endings, gradual endings, the slow cooling of a white dwarf over quadrillions of years, the imperceptible evaporation of a black hole over timescales that dwarf the current age of the universe by incomprehensible factors, the fading of the cosmic microwave background into the noise floor of the expanding void, the stretching of the last photons to wavelengths so long they carry no meaningful energy. These are not dramatic events. They are the universe completing its processes, spending its budget, moving toward the equilibrium it has been approaching since the beginning. And somewhere in this sequence of quiet endings, the fluctuation that includes you will end. Not soon, by human standards. Not in any time frame that is personally relevant to the experience of sitting in a room and following a chain of reasoning about the cosmos. But in the context of the universe's total duration, the ending is not far away. The sun will exhaust its hydrogen in roughly 5 billion years. The Earth will be uninhabitable long before that, as the sun gradually brightens and the oceans evaporate. The conditions that currently support the fluctuation we call life on Earth are not permanent. They are a phase within a phase within a phase, a temporary alignment of circumstances that will not persist indefinitely, in a universe that is moving in a direction that makes their persistence increasingly unlikely with every passing moment. This is not a reason for despair in any simple sense. Despair is a response to the loss of something expected, but the permanence of the current conditions was never something that could reasonably be expected. The physics was always pointing in this direction. The entropy was always increasing, the expansion was always accelerating, the stars were always burning through their fuel. The only thing that has changed is the clarity with which these facts can be seen, the precision with which the trajectory can be traced, the honesty with which the destination can be named. The destination is emptiness, not the emptiness of the void between galaxies, though that void will grow, not the emptiness inside atoms, though that emptiness will persist until the atoms decay, but the emptiness of a universe that has completed its processes, spent its budget, reached its equilibrium, and settled into the featureless, eventless, structureless condition of maximum entropy, a condition that is not death in any meaningful sense, because death implies a prior life, and the heat death is not the death of the universe. It is the completion of the universe. The universe will still exist. It will simply be empty in a way that makes the current emptiness look crowded. And the current emptiness is already extraordinary. The floor beneath you is mostly empty space. The solar system is mostly vacuum. The galaxy is mostly darkness. The universe is mostly void. The matter that makes up everything you have ever known is a 5% minority in a cosmos dominated by dark matter and dark energy, neither of which we understand. The expansion is carrying galaxies beyond the horizon. The entropy is dissolving structure. The stars are aging. The window is open, but it is not always open, and it will not always be open. This is the picture, not a comfortable picture, not a picture that offers reassurance or suggests that the universe is arranged with human flourishing in mind, but an honest picture. A picture built from measurements and observations and the most rigorously tested theories in the history of science. A picture that shows the universe as it actually is, not as we might wish it to be, not as it appears from the limited perspective of a human lifetime on a small planet in an unremarkable corner of a vast and mostly empty cosmos. The picture shows a universe that is, at its deepest accessible level, almost entirely empty. A universe in which matter is a trace, in which visible matter is a trace of a trace, in which the conditions for complexity are a brief and local exception to the dominant condition of absence. A universe that is expanding, accelerating, cooling, darkening, and moving inexorably toward a state of maximum entropy in which nothing new can happen and nothing old can be remembered. A universe that has produced in this particular moment, in this particular place, something capable of seeing all of this clearly, and that something is sitting in a room right now, feeling the floor beneath it, surrounded by objects that are mostly empty space, on a planet that is a speck in a solar system that is a speck in a galaxy, that is a speck in a universe that is almost entirely nothing. The view is clear. The trajectory is clear, the destination is clear, and the only thing left to ask is what it means to see all of this, to hold it in a mind that is itself a temporary fluctuation in a universe moving toward emptiness, to feel the weight of it, the scale of it, the irreversibility of it, What does it mean to be the universe looking at itself and seeing, with increasing clarity and increasing precision, that what it is mostly made of is absence? It means this: the room is real, the floor is real, the stars are real, the galaxies are real, the cosmic web is real, the expansion is real, the entropy is real, the heat death is real, and the awareness that holds all of these things simultaneously, that traces the path from the solidity of the floor to the emptiness of the cosmos, that feels the vertigo of the scale and the weight of the trajectory, is also real. All of it is real, and all of it is temporary, and the temporariness does not make it less real. It makes it more precisely what it is: a fluctuation. A brief, improbable, extraordinary fluctuation in a universe whose dominant and permanent condition is the void. The void was not the background. It was never the background. It was always the majority. It was the majority inside the atoms of the first stars. It was the majority in the space between those stars. It was the majority in the voids between the first galaxy clusters. It was the majority in the dark energy that filled all of space, even as the first structures were assembling. And it will be the majority when the last black hole evaporates, and the last photon stretches to a wavelength too long to carry meaning, and the universe settles into the featureless equilibrium of its final state. The void was always the majority. The structures were always the exception, and the exception, extraordinary as it is, was always temporary. The floor beneath you will not always be there. The stars above you will not always shine. The galaxies beyond them will not always be reachable, and most of them are already beyond reach, already carried past the horizon by the expansion, their light still arriving from the past, but their future inaccessible, their existence already effectively severed from ours by the geometry of an accelerating universe. The cosmic web is already stretching. The entropy is already increasing. The window is already in the process of closing slowly, over timescales that dwarf human experience, but closing nonetheless, in the only direction the arrow of time permits. And when the window closes, there will be no record of its having been open. Not because the events within it were unimportant, but because importance requires a mind to assign it, and minds require the conditions that the window provides, and when the window closes, the conditions will be gone, and with them the possibility of any mind to remember that the window was ever open. The universe will not mourn the closing of the window. It will not notice. It will simply continue to exist in its final state of maximum entropy, expanding and cooling and containing nothing capable of observing it, for a duration that has no meaningful end. This is the emptiness of the universe, not just the emptiness between galaxies or the emptiness inside atoms or the emptiness of the cosmic voids, but the emptiness of a cosmos that is, at its largest scale and across its full duration, a structure in which the conditions for complexity, for awareness, for the kind of organized matter that can ask questions about the universe, are the exception rather than the rule. A structure in which the void is not the space between things but the thing itself. A structure in which everything we call real and significant and meaningful is a temporary interruption in a much larger and much longer condition of absence. The interruption is real. The awareness is real. The questions are real. But the interruption will end. The awareness will end. The questions will end. And the void will remain, as it has always remained, as it was always going to remain, patient and indifferent and vast. The majority condition of a universe that was never mostly made of things, but was always, at every scale and across all of time, mostly made of nothing. There is a question that has been circling beneath the surface of everything said so far, and it deserves to be asked directly, not because it has a satisfying answer, but because the asking of it is itself significant. The question is this: does it matter that we know? Does it matter that the universe has produced in this particular corner of a particular galaxy structures capable of comprehending the scale of the emptiness, the direction of the trajectory, the inevitability of the destination? Does the knowing change anything? The honest answer is no. The knowing does not change the physics. The awareness of the expansion does not slow the expansion. The comprehension of the entropy does not reverse the entropy. The understanding of the heat death does not prevent the heat death. The universe is indifferent to whether any part of it has modeled the whole. The trajectory is the same whether or not anyone traces it. The destination is the same whether or not anyone names it. The void does not become less void because something within it has learned to measure its dimensions. The emptiness does not become less empty because something within it has learned to feel the weight of the emptiness. And yet the knowing exists. It is a physical fact, as real as the expansion and the entropy and the dark energy. The knowing is encoded in the arrangement of matter in certain brains. in the patterns of electrochemical activity that constitute thought, in the physical structures of books and databases, and the transmitted signals that carry information from one mind to another. The knowing is a real feature of the universe's current state. It is part of what the universe is right now, in this phase, in this window, and it is, like everything else in the window, temporary. But there is something about the temporariness of the knowing that is different from the temporariness of other structures. A star does not know it is temporary. A galaxy does not know it is aging. A white dwarf does not know it is cooling. The processes of dissolution that govern the universe's trajectory operate on structures that have no awareness of their own dissolution. They simply proceed, governed by the laws of physics, moving from lower entropy to higher entropy, from structure to dissolution, without any internal experience of the process. The star burns and does not know it is burning. The galaxy dims and does not know it is dimming. The void expands and does not know it is expanding, but the mind knows. The mind that has followed this chain of reasoning from the solidity of the floor to the heat death of the universe knows that it is temporary. It knows that the conditions sustaining it will not persist. It knows that the entropy is increasing, that the window is closing, that the void is the majority and will eventually be everything. It knows all of this while simultaneously experiencing the immediate reality of its own existence, the weight of the body, the texture of the air, the ordinary persistence of the world. It holds both things at once, the immediate and the cosmic, the temporary and the permanent, the fluctuation and the void. This capacity for double vision, for holding the immediate and the cosmic simultaneously, is not a comfort, it is a burden. It is the specific burden of being the kind of structure that can model the universe, that can trace the trajectory, that can name the destination. Other structures in the universe do not carry this burden. They simply are what they are, governed by the laws of physics, moving in the direction the laws require, without any internal experience of the movement. The mind is different. The mind experiences the movement. The mind feels the direction. The mind knows where it is going, and where everything is going, and cannot unknow it. And the knowing is not abstract. It is not a set of propositions held at a comfortable intellectual distance. It is a physical condition of the brain, a pattern of neural activity that persists and recurs, that shapes the way the world is experienced, that colors the perception of the floor and the sky and the objects in the room. The knowing is in the body. It is in the way the mind returns, again and again, to the scale of the emptiness, to the direction of the trajectory, to the image of the drop of ink diffusing into the pale blue of the final state. The knowing is not something that can be set aside. It is part of what the mind is, now that it has been acquired. This is the specific condition of a mind that has genuinely absorbed the cosmological picture, not a mind that has read the facts and filed them away as interesting information, but a mind that has followed the chain of reasoning all the way to its conclusion, that has allowed the scale to land, that has felt the vertigo of the temporal emptiness, that has sat with the image of the universe's final state, without immediately reaching for a way to soften it. Such a mind is changed, not dramatically, not in any way that is visible from the outside, but changed in the way that the world looks, in the way that the immediate and the cosmic coexist in the same field of awareness, in the way that the floor and the void are both present at the same time. The floor is still there, the void is still there. Both are real, both are present, and the mind that holds both simultaneously is doing something that, as far as we know, almost nothing else in the universe does. It is being aware of the full scale of what it is part of. It is experiencing the universe from the inside, while also modeling it from the outside. It is the fluctuation that knows it is a fluctuation, the temporary structure that knows it is temporary, the drop of ink that knows it is diffusing. There is no framework in ordinary human experience that prepares you for this. The frameworks we use to navigate daily life, the frameworks of personal narrative, of social meaning, of cultural significance, of the immediate future, and the remembered past, are all calibrated to human scales. They work well for the problems they were designed to solve. They allow us to plan, to cooperate, to build, to love, to grieve, to hope. But they were not designed to accommodate the cosmological picture. They were not designed to hold the heat death and the grocery list in the same mind at the same time. They were not designed for the specific vertigo of knowing that the floor is mostly empty space and the stars are temporary and the void is the majority and the window is closing. And so the mind does what minds do when they encounter something that does not fit their existing frameworks. It reaches for analogy. It reaches for metaphor. It reaches for the nearest available structure that can hold the new information without collapsing. And the nearest available structure, for most minds, is something like wonder, the reframing of the emptiness as something vast and beautiful rather than something cold and indifferent, the reframing of the temporariness as something precious rather than something doomed, the reframing of the void as something sublime rather than something simply empty. These reframings are not dishonest. They are genuine responses to genuine features of the cosmological picture. The universe is vast. The structures within it are intricate. The improbability of the current moment is real. The fact that the universe has produced something capable of comprehending its own emptiness is genuinely extraordinary. These things are true, and the wonder they inspire is a real response to real features of the universe. But wonder is not the whole response, and it is not the most honest response. The most honest response includes the wonder and also includes the weight of the scale, the weight of the trajectory, the weight of the destination, the weight of knowing that the extraordinary improbability of the current moment is not a sign of cosmic significance but a consequence of the particular phase of the universe's evolution we happen to inhabit. The weight of knowing that the window is open, not because the universe intended it to be open, not because the universe cares whether it is open, but because the laws of thermodynamics and the initial conditions of the Big Bang have produced, in this particular interval of cosmic time, the conditions that make windows possible. The weight is real. It does not cancel the wonder, but it does not disappear in the presence of the wonder either. It persists. It is the specific gravity of a mind that has genuinely absorbed the cosmological picture, that has followed the chain of reasoning all the way to its conclusion, that has allowed the scale and the trajectory and the destination to land without softening. It is the weight of knowing that the void is the majority, that the window is closing, that the knowing itself is temporary, and that the universe will not notice when the knowing ends, and the universe will not notice. This is perhaps the sharpest edge of the entire picture, the one that cuts most cleanly through every attempt to find a comfortable resting place. The universe does not notice. It does not observe. It does not record. It does not care. Not in the sense of being hostile or indifferent in the way a person can be hostile or indifferent, but in the deeper sense of being a physical system governed by laws that have no provision for caring, no mechanism for noticing, no capacity for the kind of attention that would make the existence of minds within it significant to the system as a whole. The universe is not watching. It has never been watching. The stars do not observe the planets that orbit them. The galaxies do not observe the stars within them. The cosmic web does not observe the galaxies that trace its filaments. The expanding void does not observe the structures it is pulling apart. The entropy does not observe the order it is dissolving. The universe is a physical system, and physical systems do not observe. They simply proceed, governed by their laws, moving in the direction their laws require, without any internal experience of the movement, without any awareness of what is being lost. What is being lost is everything, not all at once, not dramatically, but everything eventually in the only direction the arrow of time permits. The stars are being lost. The galaxies are being lost. The planets are being lost. The conditions for life are being lost. The conditions for mind are being lost. The knowing is being lost. And the universe does not notice any of it, because the universe has no mechanism for noticing, because noticing is a property of the fluctuations within the universe, not of the universe itself, and the fluctuations are temporary. This is the condition, not a condition that can be resolved or escaped or transcended, a condition that simply is what it is, the physical reality of being a temporary structure in a universe, moving toward maximum entropy, capable of modeling the universe's trajectory, incapable of altering it. The condition of being the drop of ink that knows it is diffusing. The condition of being the fluctuation that knows it is temporary. The condition of being the window that knows it is closing. And the window is closing, not quickly, not in any time frame that is personally relevant to the experience of sitting in a room and feeling the floor beneath you, but closing. The sun is burning through its hydrogen. The galaxy is aging. The cosmic web is stretching. The horizon is shrinking. The entropy is increasing. Every process in the universe is moving in the same direction, at different rates toward the same destination, and the destination is not a place. It is a condition, the condition of maximum entropy, the condition of the void. There is a particular kind of clarity that comes from following a chain of reasoning all the way to its conclusion without flinching. Not the clarity of resolution because there is no resolution here. Not the clarity of comfort because there is no comfort here. But the clarity of precision. The clarity of knowing exactly what the universe is, exactly what it is doing, exactly where it is going, and exactly what that means for the temporary structures within it that are capable of knowing these things. It is a cold clarity, A clear-eyed clarity. The clarity of a mind that has looked at the full picture without softening it and has allowed the full picture to be what it is. The full picture is this. The universe is approximately 13.8 billion years old and will exist for a duration that is, for all practical purposes, infinite. The conditions that currently support complexity occupy a tiny fraction of that duration. The matter that makes up everything we have ever known is a 5% minority in a cosmos dominated by dark matter and dark energy. The visible structures of the universe, the stars and galaxies and cosmic web, are temporary arrangements of that minority, sustained by the flow of energy from concentrated sources to diffuse sinks, moving inexorably toward dissolution. The expansion is accelerating, the horizon is shrinking, the entropy is increasing, the window is closing, and within the window, in this particular moment, in this particular place, the universe has produced something capable of seeing all of this clearly. That something is you, not you in the sense of a special or chosen or cosmically significant entity, you in the sense of a temporary arrangement of atoms that has, through the extraordinary improbability of biological evolution and the specific conditions of this planet and this star and this galaxy and this moment in cosmic history, acquired the capacity to model the universe, to hold the Big Bang and the heat death in the same mind, to feel the vertigo of the scale, to trace the trajectory, to name the destination, to know that the knowing is temporary and that the universe will not notice when it ends. You are the universe's self-portrait, drawn in the medium of temporary matter, in the brief window of the stelliferous era, on a small planet in an unremarkable galaxy, in a cosmos that is mostly empty and getting emptier. The portrait is real, the medium is real, the window is real, and the portrait will not last. The medium will dissolve, the window will close, and the universe will continue, without the portrait, without the medium, without the window, in the featureless equilibrium of its final state, for a duration that makes the entire history of the portrait look like a single brushstroke on a canvas the size of the observable universe. A single brushstroke. That is what the entire history of complexity amounts to, on the full timeline of the universe. A single, brief, improbable brushstroke of organized matter in a cosmos of expanding void. The brushstroke is real. It is intricate. It is extraordinary in its detail and its improbability, but it is a brushstroke, and the canvas is almost entirely blank. The canvas was almost entirely blank before the brushstroke. It will be almost entirely blank after the brushstroke. The blank canvas is not the background. It is not the space between the marks. It is the canvas itself, the dominant condition, the majority state, the thing the universe mostly is and mostly will be. The brushstroke is the exception. The blank is the rule. And the rule does not care about the exception. The blank canvas does not observe the brushstroke. The void does not observe the structures within it. The entropy does not observe the order it is dissolving. The expanding universe does not observe the galaxies it is carrying apart. The heat death does not observe the complexity it is ending. The universe is not a witness to its own history. It is a physical system, proceeding according to its laws, indifferent to the extraordinary improbability of what has briefly occurred within it. What has briefly occurred within it is everything, every star that has ever burned, every planet that has ever formed, every ocean that has ever moved, every cell that has ever divided, every mind that has ever thought, every question that has ever been asked about the nature of the universe, every answer that has ever been found, every moment of awareness, however brief, however local, however improbable, all of it has occurred within the window. All of it is part of the brushstroke, and all of it is temporary in a way that the blank canvas is not. The blank canvas is patient. It does not need to wait, because waiting implies the experience of duration, and the blank canvas has no experience. It simply is what it is, the majority condition of a universe that was never mostly made of things, that was always mostly made of nothing, that is moving toward a state in which the nothing is complete and the something is gone. The blank canvas does not anticipate the end of the brushstroke. It does not prepare for it. It does not notice when it happens. It simply remains as it has always remained, as it will always remain, the dominant and permanent condition of a universe that briefly, locally, improbably interrupted itself with complexity. The interruption is ending, not now, not soon, by any human measure, but ending. The processes are in motion, the trajectory is set, the destination is named, and the mind that has followed this chain of reasoning to its conclusion is sitting in a room right now, feeling the floor beneath it, surrounded by objects that are mostly empty space, on a planet that is a speck in a solar system, that is a speck in a galaxy, that is a speck in a universe that is almost entirely nothing. Knowing all of this, unable to unknow it, and continuing to exist anyway. This is not a triumph. It is not a defiance. It is simply what temporary structures do while they are still temporary rather than ended. They continue. They proceed. They burn through their low entropy budget, one moment at a time, one thought at a time, one heartbeat at a time, moving in the only direction the arrow of time permits, toward the equilibrium they will eventually reach. The continuing is not a choice. It is a physical process. The mind continues to think because the electrochemical processes that constitute thinking are still operating. The heart continues to beat because the biological processes that constitute life are still operating. The star continues to burn because the nuclear processes that constitute fusion are still operating. Everything continues until it stops, and everything stops. But before it stops, it is real. This is the last thing that can be said honestly about the emptiness of the universe, and it is not a comfort, but it is a fact. Before the brushstroke ends, it is real. Before the window closes, it is open. Before the drop of ink diffuses, it is visible. Before the fluctuation ends, it exists. The reality is not diminished by the temporariness. The temporariness does not make the reality less real. It makes it more precisely what it is, a temporary reality, a real temporariness, a genuine, physical, measurable, undeniable fact about the current state of the universe that will not always be a fact about the state of the universe. The floor beneath you is real. The stars above you are real. The galaxies beyond them are real. The cosmic web is real. The expansion is real. The entropy is real. The void is real. The knowing is real. And the knowing that the knowing is temporary is real. All of it is real, simultaneously, in the same universe, in the same moment, in the same mind that is sitting in a room right now, feeling the weight of all of it, unable to set it down, unable to resolve it, unable to find a resting place that is both honest and comfortable. There is no resting place that is both honest and comfortable. This is the final thing the cosmological picture offers. Not comfort, not resolution, not a framework that makes the emptiness feel like something other than what it is, but honesty. The honesty of a picture built from the most precise measurements ever made of the universe's structure and composition and trajectory. The honesty of a description that does not soften the scale, does not minimize the emptiness, does not pretend that the window is permanent, or that the brushstroke is the canvas, or that the fluctuation is the equilibrium. The honesty of saying, this is what the universe is, this is what it is doing, this is where it is going, and this is what it means to be a temporary structure within it that is capable of knowing all of this. It means sitting in a room that is mostly empty space on a planet that is a speck, in a galaxy that is aging, in a universe that is mostly void and getting more so, knowing that the floor will not always be there, that the stars will not always shine, that the knowing itself will not always exist and that the universe will not notice any of it. It means holding the immediate and the cosmic simultaneously, without resolution, without the comfort of a framework that makes them fit together neatly, without the reassurance that the extraordinary improbability of the current moment implies anything about its significance to the universe as a whole. The universe does not assign significance. It produces conditions. In this particular set of conditions, significance has emerged as a property of certain temporary structures. Those structures assign significance to things. They assign it to each other, to their experiences, to their histories, to their questions and their answers. The significance is real within the structures. It is a genuine feature of the current state of the universe, but it is not a feature of the universe's laws. It is not written into the physics. It is not preserved by the thermodynamics. It is a local temporary property of a local, temporary fluctuation in a universe that is, at its largest scale, and across its full duration, indifferent to whether significance exists or not. The indifference is complete. It is not the indifference of a person who has chosen not to care. It is the indifference of a physical system that has no mechanism for caring, no capacity for attention, no provision in its laws for the preservation of what matters to the structures within it. The universe will not save the knowing. It will not preserve the record. It will not maintain the conditions that make significance possible. It will simply proceed, governed by its laws, moving in the direction its laws require, dissolving the structures that have briefly interrupted its dominant condition of emptiness, returning to the equilibrium it has been approaching since the beginning. The equilibrium is the void. The void is the destination. The destination is not far away in any meaningful sense, because the timescales involved are so vast that the concept of distance in time loses its ordinary meaning The destination is simply where the universe is going, where it has always been going, where everything within it is going at different rates by different paths, through different sequences of dissolution. The stars will get there, the galaxies will get there, the planets will get there, the minds will get there, the knowing will get there, everything will get there. And when everything has gotten there, the void will remain, as it has always remained, patient and complete and indifferent, the majority condition of a universe that was never mostly made of things. Look at the floor. It is still there. It is still solid. It is still mostly empty space. The atoms that make it up are still mostly void. Their electrons orbiting their nuclei at distances that, scaled to human size, would place them miles apart. The floor is real, and the floor is mostly nothing, and both of these things are true at the same time, in the same floor, in the same universe, in the same moment. This is not a paradox. It is a description, a precise, honest, scale-dependent description of what the floor actually is at the level of its actual physical constitution. And what the floor actually is at the level of its actual physical constitution is a temporary arrangement of mostly empty atoms held together by electromagnetic forces, resting on a planet that is itself a temporary arrangement of mostly empty atoms, orbiting a star that is burning through its hydrogen, in a galaxy that is aging, in a universe that is expanding and cooling and moving toward the equilibrium of maximum entropy. The floor is real, and the floor is, at every level of description below the scale of ordinary human experience, almost entirely nothing, almost entirely nothing. This is the universe's most honest self-description, not the stars and galaxies and cosmic web that fill the night sky with apparent richness, not the solid objects of daily experience that give the impression of a world full of things, but the emptiness inside the atoms, the vacuum between the stars, the voids between the galaxy clusters, the dark energy filling all of space, the expanding horizon carrying structure beyond reach, the entropy dissolving order, the heat death waiting at the end of the arrow of time, almost entirely nothing, at every scale, across all of time, in every direction, and in the middle of the almost entirely nothing, for a brief and improbable interval, something. The something is real. It is extraordinary. It is the universe's most complex product, the most intricate arrangement of matter that the laws of physics have produced in the known history of the cosmos. It is stars and galaxies and planets and oceans and cells and minds and questions and answers and the specific awareness of sitting in a room and knowing that the room is mostly empty space and the universe is mostly void and the knowing is temporary and the void is not. The void is not temporary. This is the final fact. Everything else is temporary. The stars are temporary. The galaxies are temporary. The planets are temporary. The minds are temporary. The knowing is temporary. But the void is not temporary. The void was there before the first star. The void will be there after the last black hole. The void is the universe's permanent condition, interrupted briefly by the extraordinary improbability of structure, and returning to itself as the structure dissolves. The void does not end. It does not age. It does not cool or dim or fade. It simply is and will be and was the majority condition of a universe that briefly, locally, improbably contained something other than itself. The something is almost over. Not now, not soon, but in the only sense that matters on the full timeline of the universe. The something is already in its final phase, already past the peak of its complexity, already on the long slope toward the equilibrium that was always its destination. The stars are aging, the window is closing, the brushstroke is fading, and the blank canvas is waiting, as it has always been waiting, not with anticipation, because waiting implies experience, and the blank canvas has no experience, but simply as the condition that was always the majority. That is becoming more so with every passing moment, and that will eventually be everything. The blank canvas will eventually be everything, and you are sitting in a room right now on the brushstroke in the window knowing this, feeling the floor beneath you, breathing the air around you, existing in the specific, improbable, temporary way that the current conditions permit. The universe does not know you are here. It does not know the window is open. It does not know the brushstroke is real. It simply proceeds, governed by its laws, indifferent to the extraordinary fact of your awareness, moving in the only direction it has ever moved, toward the void that was always the majority, that is always becoming more so, and that will, in the end, be all there is.